Good morning and welcome. Thanks for joining our event. We've needed to change things up a little bit this year. We've pre-recorded all of our talks and we'll be live streaming them throughout the day starting at 10 o'clock. And at the end of the day, we're going to post them up on YouTube and link them on our website. We've tried to make this year as interactive as an in-person event would have been. We've got a capture the flag running, which people have been hacking away at for the last couple of days, and we've joined with the Hack South Discord channel where all the different guests that have joined and different speakers are as well. So while you're watching the talks, if you want to talk to the speaker about the research that they've done, then you can reach them there. I'll leave links to both of these in the description below. Thanks for joining. I hope you enjoy the day, I hope you enjoy the talks, and I hope you learn something new. I'll see you on Discord.
Hello everybody, welcome to Routopsy, Modern Routing Protocol Vulnerability Analysis and Exploitation. I'm Tyron Kemp and I work with this project along with Simon Zhukovsky. At the time we were both pen testers at SensePost. Simon is a lead Axor, he likes AppSec and writing code. I'm a bit of scrub. Unfortunately, Simon can't join us for this one, so he's stuck with me. I have some network security experience, and I've done some pen testing, and how this sort of, just give you some background, how the project came about. I think it was a SenseCon, myself and Simon wanted to do something, and he wanted to learn about some networking stuff, and I wanted to learn how to write better code. I think Simon learned some networking, and I still write really bad code. But here we are, and we want to show you how to identify some of these network-related vulnerabilities, how our initial attempt looked at attacking some of them, what was the impact thereof, and what are the challenges that we faced and that you may face, and how the toolkit attempts to overcome some of those challenges. So we went on some pen tests, and on recurring occasions we saw these vulnerable DRP and FHRP protocols being multicasted into user space, which they shouldn't be. So maybe our initial idea was to build this toolkit that would attack any network-related protocol, and that would be cool. But for now, we're focusing on these two things, and we'll go into them and explain them a little bit better and what the differences are, etc., etc. In the DRP stack, we're going to focus on EIGRP and OSPF, and then in the FHRP stack, we're going to focus on HSRP. So I realize that they sound the same and it's a bunch of acronyms coming your way, but just try and keep that in the back of your mind and you should be okay. Why are we doing this? We saw this in multiple different environments, not being bound to any sort of same topology or industry or anything. We were seeing them across the plethora of different customers. Also, dynamic routing protocols are being used in Kubernetes. They use these things called CNIs, Container Network Interfaces, I think is the correct acronym. And you can see on the slideshow it mentions Calico and Romana. Calico uses BGP and Romana uses OSPF. Simon did most of the work on the Kubernetes stuff. I think I showed him sort of some BGP stuff, and then he ran with it to get some pwnage. Some of that's been taken out of this presentation because it's just really more Simon's work. But before we get into DRPs and FHRPs, let's explain what a static route is. So for us to route traffic from the 10 network to the 40 network, we need to add a static route from A to B, from B to C, from C to B, and B to A. And that's obviously not a great process. It's quite tedious and manual. So now you move over to a network or a company with 100 routers and 1,000 networks. Imagine having to configure a static route for each network to get to each other network, and you need to take care of redundancy as well. So that's sort of what I tried to depict in the middle of that image. You might configure 2 routes between the same networks on different links. So if the one link drops, your second static route with a less or higher priority will take over. It's not very feasible. So luckily we have these things called dynamic routing protocols. Like I said, we're going to focus on OSPF and EIGRP, So what you would do is you would hop onto that router and you'd configure the protocol with its parameters on each router, and it would automatically share the routing and networking information, and it would automatically, based on its own algorithm, connect which is determine which is the best path between the networks, and then if that link drops, the redundant path would automatically kick in. FHRPs, it's more of a high availability mechanism. So you can see the user A by default uses the user A's traffic traverses through that switch, and then it goes through that active router. So that active and standby router form part of sort of a logical group within HSRP or VRRP, and there's a priority assigned to it, and then once the one fails over, there's also a virtual MAC address assigned to this group and a priority. So if the active device were to fail, then that virtual MAC address would just switch to the other device, and the user's traffic would get routed without knowing anything had happened on the network. Okay, so how do you look for these things? In terms of EIGRP, I think I mentioned multicast earlier, so you can see in the packet capture at the top there, it's going to a 224 address. So many of these attacks are because things are getting multicasted into networks that they shouldn't. But to get into more EIGRP specific stuff, in this packet, the only thing we really need to look out for is the autonomous system number, and that's all these parameters you need to take note of, and you just need to configure it on your attacker or rogue router type of thing. So in that instance of EIGRP, we didn't see that there was any authentication present, so it's pretty simple. You take that info out of the PCAP and you build your config and you attack or join the routing process. But it is possible to add authentication to these things. So there's two variants. There's the clear text auth, which is not that great because you can just observe it as well. And then there's a sort of hashed alternative, but it's not game over when there's crypto applied. You can get the hash for certain algorithms using Ethercap, and then you can crack it with John the Roper. And often these things are configured with passwords like password or key or Cisco. So if you go onto like how to configure Cisco OSPF authentication, the guides are always using sort of weak passwords, so you can try and guess it as well. So if we look at this EIGRP packet, you can see there's some hashing applied to it. There's no password or string or anything that we can observe there. Again, we can pass this thing to Ethercap, and we can try and crack the hash to join the routing process. If we look at a OSPF packet, there's a little bit more to consider as opposed to EIGRP. We have to take note of that area ID, quad 0, and then this is the plain text variant of auth that I spoke about. So there's auth, but you can observe it in plain text, so it's not really useful. And then we need to take care of or take note of the hello interval and the dead interval. Okay, cool. So moving over to the FHRP stack, if we look at an HSRP packet, which is a Cisco proprietary protocol, you need to make sure that you're looking at the active router's hello packet, not the standby, because you want to assign yourself a higher priority as the active. If you're just higher than the standby device, you're not going to become the active guy. So make sure you're looking at an active packet. You need to take note of the hello and the hold time. Those are sort of the default values, so you'll often see them as 3 and 10. And then you can see on this router the priority is 150, so we just need to go up and we can become the active device. That logical grouping I was speaking of, this is for group 10. You'll need to take note of that. And then you can see here again there's the default plain text auth applied, not super useful, and then a virtual IP address assigned to the group, which you will effectively become that virtual IP address once you attack the protocol. So how do these things creep into the network? Minimalist config is one way. So if you look at this config extract, you can see that that router would advertise OSPF hello packets on all its interfaces based on that quad 0 that you're seeing. So you might see something like this, which is a little bit better. It's saying /24 and /25. But that router may not have those interfaces. That router may have like 2/25s on that 10 network, and then you might only want to speak OSPF on the one interface within that /24, but it's actually 2/25s. Yeah, you have to be very specific. So you could have had configured OSPF on the interface, or you could have said /32 to make sure that it only goes out of the one interface that you wanted to go on. And so these are the errors that admins are making and that we can abuse. Again, in the Kubernetes world, you can see there, this is a Ramona an example of a Ramona configuration, and you can see there's an asterisk in the interface field. So if you're a Kubernetes admin, you might be dealing with a bunch of different OSs. We don't use Eth0 anymore. We have these funny ENS33, ENS123 numbers, and it's different between OSs. So it might be the easiest thing just to use the wildcard to make sure that your OSPF process comes up. But again, this minimalist config is an issue where you should really be strict with your config. It's like configuring an ACL. You've got to be very specific. Okay, so we have a bit of an understanding of how these protocols work and how some of the vulns introduced. It's also important to know where they live within the network. So if we consider ourselves connected to a switch, you'll be likely to see an FHRP, something like HSRP providing you with that default redundant default gateway we've seen in the previous slides. If you manage to pivot or move throughout the network and you find yourself connected to a LAN where a router or a firewall is connected, it's likely that you'll see a DRP being multicasted into that network or VLAN, because that's what those devices speak. Routers and firewalls often make use of VRRP for high availability as well. So two firewalls connected together, they speak VRRP between each other. Sometimes that can be configured incorrectly as well, and we can take advantage of that. Lastly, we mentioned Kubernetes. CNIs make use of dynamic routing protocols. So maybe if you end up in that router network and you tamper with traffic, you may be able to affect routing within Kubernetes, or maybe you've landed in the Kubernetes, somewhere in Kubernetes where you can affect one of these CNIs, and you might be able to impact routing in the traditional network as well. Okay, so what's the impact of exploiting these vulnerabilities? Well, consider yourself connected to a network, as indicated on the slide. You know of some hosts on your network because you have an ARP table, and you know about your default gateway probably as a result of DHCP. But now you start interfacing with either OSPF or HSRP, and you join the process and you learn of some new networks. So now you learn of the finance network and the server network, and you have some new targets. So that's pretty cool. You didn't have to go nmap /8 or /16. You learned with these things in a quite stealthy manner. But we want to go a little bit further. We want to see if we can manipulate traffic flows. So there's a finance user connecting to an ERP server in the server network. And from our attacker's perspective, we know what that network is. So what we can do is we can inject a more specific route into the routing process. And what will happen is that traffic will then be redirected towards us. And you can imagine, that redirecting ERP traffic towards your attacker machine could have some devastating impacts. For FHRPs, we mentioned there's this logical group with a virtual IP address and a virtual MAC. And there's a priority assigned, and the device with the highest priority is the active one, and traffic is routed towards that device. So from an attacker's perspective, we give ourselves that higher priority. Traffic is directed towards us, and we route that traffic upstream to the legitimate default gateway, essentially establishing a person-in-the-middle attack. So for DRPs, we need to get specific, and what we mean by that is you need to try and inject a more specific route into the routing table, sort of to beat the routing table entry. If you add a /24 route on your machine and a /25, the traffic's going to go towards the /25. That's just how routing works. There's more specific stuff like per protocol metrics or per protocol specific metrics and something called the administrative distance. But for now, just know that you need to try and be more specific with your routing entries to beat the routing table. So how did we do this initially? We were connected to a LAN. We opened up Wireshark exactly like we showed, and we saw some unauthenticated HSRP packets, I think it was, and we wanted to attack it. So, we did some research. Is there any tooling available? There was, but it was easier for us to configure a virtual firewall, and that's sort of the route that we took. And I'll show you what that looked like. So on the left hand side, there's a Wireshark capture, and we see some OSPF hello packets. So you should already get excited when you see that. You shouldn't really see those things on a user network, regardless of whether there's auth or not. And then on the right hand side is our rogue attacker firewall. And we're just going to match the parameters on the left, configure the firewall, and we should join the routing process. So for OSPF, there's a couple of things that we need to take note of. Look at the auth, null, so this is going to be an easy attack. We look at the area ID, quad 0, that's important to OSPF. We look at the hello and the dead interval, 10 and 40. So with that knowledge, we're going to map that into the FortiGate. So we're going to give ourselves a router ID, which is just the unique identifier within the process. We're going to add the area, which we know is quad 0 now. And then we're going to say we want to speak OSPF out of only one specific interface. We'll get this IP out of the URL bar, the only interface that this firewall has. And that's, we are only sending hellos out of that one interface. And again, on the FortiGate, we need to add the interface, give it a name, specify the interface, and over here we'll configure the hello and dead interval, which we got from the packet capture as well. So on the left hand side now you should see an OSPF conversation happening. It shouldn't take too long. 1, 2, 3, there we go, and we see some OSPF stuff happening over there. And in those LS update packets is where the routing information is shared. So on the right FortiGate you can see there's not much routes over there. Once we refresh the routing table or the routing monitor, you should see that we've learned a bunch of new networks. So that's pretty cool. We haven't attacked anything really, we just joined the process, but now we have new targets to go after, and that could be useful from an attacker's perspective as well. So what's the downside with this? Downside of this approach, you need to have access to firmware, like a FortiGate or something that's able to speak these protocols. You need to have knowledge of the protocol, so you need to know how OSPF, HSRP, or whatever works to attack it. And so the old tools, we weren't successful using the old tools to attack these protocols. We started seeing a pattern, and the pattern was, all you have to do here is pause a PCAP, extract some stuff, build a config template, map it to a router, and then boom, profit. So that's sort of how Routopsy came about. And how do we build this thing? Well, we use Python, we leverage Docker quite a bit, and then probably the most prominently used Docker container is something called FR routing. It's an open source router, similar to something like Quagga or Bird, but this one seemed quite nice, and it suited our needs quite nicely. And that's sort of the composition of Routopsy. And Routopsy was built using this sort of scan, attack, and inject methodology. So you can scan for things. So you don't have to open up Wireshark. You can just run scan, and it will do the scanning and detection of vulnerable packets for you. And then the attack flag will join the routing process and just do that sort of enumeration thing that we've showed you. And then if you want to go one step further and you want to start injecting stuff, you'll use the inject or redirect flag. There's a couple of variants, but there'll be some demos on that. But this is sort of the methodology: scan, attack, and then take it one step further. So go slowly and just do it step by step until you get your pwnage. Learning new routes is cool, but it's much cooler intercepting and redirecting traffic. So before we start with the demo, we're just going to orientate ourselves a little bit. There's quite a bit going on. On the top left, we have our attacker machine's routing table. We're running a watch command over there, and you can see there's not many routing table entries over there. On the top right, we have our attacker machine again, and that's where we'll run our Routopsy commands. So the top is attacker stuff, and the bottom we have a router we're going to attack, and which we can call the victim router, And then at the bottom we have a victim doing some DNS queries and generating some FTP traffic. So at the top is attacking stuff, at the bottom is victim stuff. So let's get into it. Like I mentioned, just the routing table. We'll hop over to the other panes and explain them a little bit more in depth. On the right hand side, Routopsy, and you can see there we've specified the scan flag. You can take note of the IP address, put it in the back of your mind, 170. The route on the left has two OSPF neighbors at this point in time, and that's the IP address for the router. It's 76.208. After our attacks, you'll see that there will be 3 neighbors instead of 2. So nothing's happened just yet. There's the DNS query I was speaking about, and there's the FTP traffic. We're going to open up Wireshark, and we're going to show you that there's no interception or redirection or anything like that happening at this point in time. And we'll start off with the scan command, and the scan command is just going to identify a vulnerability and build a config template, but it's not going to map that template. So once it identifies the vuln, we'll have a look at the templates and just go through them. So we're looking at the HSRP and OSPF config. HSRP one, we just had to parse the autonomous system number 100, like we saw earlier. Quite simple over here. You could, if you wanted to, go configure this on another router or something that you wanted to play with, and you would join this process. So let's look at OSPF. This one's a little bit more involved. It has this hello and dead interval that we spoke of as well. And then the network statement is just our interface again, saying only send out hellos on this one interface, and we parse the area ID out of the vulnerable OSPF config as well. But nothing's happened. We just identified the vuln, but we want to attack stuff. So we could attack stuff, and then you would just say attack, but that's boring. We've showed you that using the FortiGate. We want to show you an inject and a redirect, which is a sub command of attack, if I can call it that. And they are similar in the way the config templates are built. With the inject flag, traffic will be routed towards your default gateway. With the redirect, the traffic will stop on your endpoint, which is useful maybe for a honeypot, or if you just want to soak at the traffic elsewhere or do whatever you want. It's just a slight difference in those two. You'll see some activity on the rest of the screen. We'll go through that shortly, but let's just first have a look at the config templates for the inject and the redirect. At the bottom left, you can see the OSPF process is going up, and there we've learned some routes. That DNS query has now changed to 1337, and our FTP traffic went from 3 ops to 4 ops. So what's happened? What did we create? What happened? So if we look at the config template of Routopsy, you can see there's some static routes at the top there, going to the null interface, and you may start to ask yourself, why are we routing things towards the null interface? Surely we're going to drop that traffic. And you can see there on our end in the Linux kernel, it's also showing it's getting dropped, but we have a way to get around that. In the OSPF process, we say redistribute, and we can prove to you that it's really within the routing process. So on the victim router, you can see there quad 8 and that 164 address has been added to the routing process. Okay, so what happens if the traffic is routed towards us? We make use of policy-based routing, those PBR maps, to take care of the traffic. We don't want to drop it, we want to route it. So you can look at that policy-based map, and it will match the address that we specified in our flags, in the inject and redirect flags. And then they're just saying forward it onto the default gateway. But for redirect, there's a natural forcing the traffic to stop on your endpoint, which may or may not be useful depending on your scenario. You don't have to use our config templates. You can use your own. Let's log into that FTP again, just to prove that it's really doing something. List the directory, hop over to Wireshark, and you'll see that we've redirected that FTP traffic, which is pretty nifty. Okay, so that was the redirect and inject flags. and I just want to reiterate what we did because there was quite a bit going on. We identified vulnerable OSPF and EIGRP packets using the scan flag. We opted out for the attack flag. We went for the inject and redirect, which implies attack. It built those config templates and it mapped it into a Docker container, and we were able to manipulate the traffic flow because we influenced the routing table of a victim router that didn't have authentication applied, or it was maybe configured in a way that it was sending out hello packets to somewhere it shouldn't have. But there's another attack included in the toolkit, which is sort of subcommands of the redirect and inject flags, which we're calling sort of the local attacks, and we can manipulate traffic coming inbound to your local subnet, not going out of your local subnet. So if you're the attacker and you find yourself on a network where there's a server, the victim would traverse through the network and connect to the server. We can say to the OSPF or EIGRP process that we have a better route to that server, and then the traffic would come to us and then back to the server. But this is only in the incoming direction. We're not performing a full person in the middle. The server's traffic, if the server initiates traffic to the internet or something, it's not going to go through us first. But we'll show you that it's still pretty useful. And I mentioned this, that those blue arrows will essentially change to the red ones. If the victim connects to the server, it will come to us first, and then we'll forward it onto the server, and so we'll respond however it wants to. So for this attack, we have two containers. We have an inner and an outer, and the inner one is depicted as the peer router, and the outer one is depicted as Routopsy. So how this works is the peer router is doing that static route that I've showed you and the redistribution. And then so Routopsy is configured with, let's say, OSPF, and it's speaking OSPF to the inside, to the peer router, and it's also speaking to the normal network, the customer network or the victim network. And then the peer route is injecting a route into the process, and on the Routopsy, on the outer container, what we do is we ignore that update. It propagates through the rest of the network, and when the traffic comes back towards Routopsy, because it's supposed to go to this inner peer, because we've ignored it, we can process it in the way that we want to, and that way we do with what we want, and then we send it to the server, and it doesn't go back to that peer router which it was advertised to go back to. So I will show you how that looks as well. Slight orientation again, but hopefully you're a little bit familiar with the setup by now. It's again, top left is the watch on the routing table command. Top right is where we'll be running netcreds to see if we can catch some hashes, and then the bottom left we have the router, and the bottom right we have a victim that's going to connect to a share. So this victim is obviously on the same network that we are on. Okay, so routing table, netcreds, we'll run netcreds, we'll log into the SMB share, show you that there's nothing going on, and then we'll run our attack again, and we'll do the same thing, and we'll show you the difference. So we connect to the SMB share, and we do like a directory listing or something just to generate some traffic. We'll log in now. Let's do ls. Okay, cool. And you can see netcreds hasn't caught on, it hasn't done anything. We haven't performed our attack as of yet. So let's run our Routopsy command and see if we can manipulate that traffic flow as well. And you can see now it says inject local instead of inject. And then again, this implies scan, it implies attack, and then the inject local is just the variant of the inject attack. So we've built those config templates. You can see them there, and now it's building two containers, this inner container and this outer container. And we'll have a look at their configurations as well. We'll look at the inner one first. You can see peer FHRP, and once that comes on, you'll see that IP route that you're familiar with, and then that redistributes static into the process again. And that's pretty much all that the inner one does, and then the outer one is gonna do a little bit more smarter work. In the top left, you can see that we've joined the OSPF process, and we've learned those routes. So let's look at the outer containers configuration, which is the template that was applied, and you can see there's a little bit more going on here. So from the top to the bottom, you can see there's two network statements. So the one is going to the normal network and the one is going to the container. And then there are these access lists, and the one is matching that address that we've shared from the inner container. And what we're going to do is we're going to apply some route maps, which allows or denies things from your routing table. And you can see access list 10 is matching route map entry 1. So we're going to say drop routing table entries for that address, and then route map 2 is going to permit the rest of the traffic, so that we don't drop all the traffic. And then that final IP protocol OSPF route map is just ensuring that that route map is actually applied to OSPF. So there's a little bit more coolness happening over here, and we will now demonstrate how we've person in the middle, or half person in the middle, the incoming traffic from the victim. So let's run netcreds again now that this config has been applied, and we can see the bottom left there's some OSPF that happened. We connect to the SMB share, and we wait for the authentication to go through, and boom, there's an NTLM v2 hash. So that's pretty cool, pretty nifty attack. Didn't really see those in any of the other tools, so that was quite nice. Yeah, just to go over it again, this is for incoming traffic on your local subnet only. So it's quite a specific use case, but nonetheless it's pretty cool. Now let's demo some of the FHRP related stuff. So the high availability protocols that provide that redundant default gateway. How do these attacks look? Let's do the same little bit of orientation again. Top left we have our attacker machine, and then on the right hand side we have the victim running a trace route, and you can see there's 17 hops to quad 8, and the first hop is going to 10, 20, 31, and that will change after we run our attack. And then in the bottom left is our vulnerable HSRP router. Okay, so over there you can see the state is active on that router, priority is 150, and the group is 10, and there's the virtual IP that we spoke about. So nothing cool yet, and we'll go over to the attacker machine and we'll run our Routopsy command. You'll see that it'll look slightly different to the DRP related stuff. So we're saying HSRP, and there's a count flag now specifying how many HSRP hello packets should we be sending. And we run the attack, which again implies scan. It will find the vulnerable protocol, parse the config, and map it to a container. The same methodology is applied here as well. So we're just waiting for that to kick in. Okay, there we go. You can see the state change over there. Something else has become the active HSRP device. We'll have a look at that now. Okay, another state change. Okay, let's look at it again. You can now see that this device has become standby. It's also, the active device says 10.20.30.3, and on the trace route you can see the first hop is now going to 3, and we have 18 hops. So traffic will go from the victim to us first, and then we'll route that traffic onto the original 10.20.31 gateway address. So with these attacks, there's obviously some case, or maybe it's not so obvious, but there's a case for denial of service. So with the FHRP related stuff, you're personing in the middle an entire subnet on your laptop or machine's network cards. Maybe you have 100 megs or a gigabit network card, and there's 10 gigs of traffic traversing through that network. So you got to be a little bit careful when you're doing that. There are some safeguards built into Routopsy, like the packet count, that type of thing. But it's just, or maybe you haven't enabled IP forwarding, and then you denial of service that entire network. But that Routopsy does all of that for you. But it's just something to consider when doing these attacks with FHRPs. Regarding the the DRPs, I know we said we get specific. Defenders can get specific again, can also get specific. For the DRPs or HSRPs as well, really apply that authentication that we mentioned, get more specific with your network statements, and then obviously you can collect syslog on these things. So it's really not that hard to configure these things correctly. Just be strict. And for DRP stuff, if there's a neighbor state change, you can collect syslog for that. If you have a new active device in your FHRP, you can send syslog to that. Maybe include that in your SIM configuration to detect these type of things. So we have something called the playground. We realize that everybody doesn't have networking kit lying around to play around with these things, or familiar with network emulators. We use something called EvenG quite a bit. If you're not familiar with that type of thing, you can simply head over to our wiki and run these YAML files with Docker Compose. And the DRP file will spin up a victim, a router, and then the Routopsy container. And then if you run the attacks, the traffic will traverse from the original path to towards Routopsy and then back out to the normal network. And then for the FHRP one, there's 2 VRRP containers that will be configured, a victim, and the victim will originally go through the VRRP containers and then through the traditional network, and then after you run Routopsy, the traffic will first be redirected towards you and then back upstream. So feel free to play around with those ones. What's the takeaways of this talk? Network protocol security is still critical. It's possible to meaningfully show impact using Routopsy, and as I just mentioned, securing and detecting doesn't look like a really hard thing to do. But it doesn't seem to be the case, and we've seen a lot of vulnerable configurations in the past. Thank you very much. I appreciate your time. If you want to have a go or play around with the tool, head over to SensePost's GitHub account. You can probably reach out to me or Simon on Twitter, or go onto the SensePost Twitter. I'm sure you'll get hold of us if you have any questions or you want to maybe contribute to anything. Yeah, thanks.
Hey everyone, and welcome to my talk today. In order to have future foresight, it requires that we look back at events that have already taken place. And that is what I'll be doing in my talk today. I'll be presenting a retrospective of 2020, looking at all of the major security news and events that have taken place in the past year, as well as some commentary and analysis from myself. This is the third year that I'm presenting such a talk at this conference, although this year is under slightly different circumstances. Just a quick introduction about myself. I'm a cloud architect. I specialize in security and enterprise cloud architecture. My research interests include privacy, security, and disinformation. I have a number of AWS certifications and working on getting some additional certifications over the next year. I have a new upcoming website called Critical Void, which explores the intersection of science, technology, and culture through the lens of information security. It's not public yet, but will be in the near future, and I hope that you will read it when it is public. My Twitter handle is @JaredNordio. I will be tweeting out a Twitter thread throughout this talk with links to some of the things that I'm going to cover in this talk today. So my talk will cover 2020, including all of the major news stories, including COVID-19, which is the major theme of 2020, with some additional themes around that, which includes phishing, disinformation, online game cheating, the insider threat, satellite security, and some of the trends that we've seen in malware and ransomware over the past year. The first major theme is remote working. So as the pandemic took over and infection started to spread across the world, we saw a lot of hoarding taking place, and people started going into lockdown from the first week of March. By April, at least 80 countries had some form of lockdown in place, and people had to start working remotely from home. Many countries already had some kind of remote working before the pandemic took over, with the Netherlands leading the pack at about 14% of the population having some kind of remote working agreements already in place. So some of the major challenges that companies experienced with remote working was that they didn't have enough laptops to send home to their employees, since many of them rely on desktop machines. Many companies had to go procure additional laptops, and with the shipping restrictions in place, this was quite a challenge. Many of them had to resort to second-hand laptops or laptops that were destined to be recycled. Companies also allowed their employees to use personal devices, and many of these devices were shared in the family. So mom and dad would use the device during the day, and then the child would use the device in the evening to play games on. This poses a massive security threat because the child would often download unwanted software or potentially malware, which would put the information stored on that device at risk. Many companies also lacked BYOD, or bring your own device, or as I like to call it, bring your own disaster policies. Many families experienced problems with space, not having, dedicated offices, or sometimes having to share space in their apartments, which could sometimes cause problems. VPNs were another big problem, where concentrators were not designed to handle the load that they were expected to handle, and new concentrators had to be purchased. Threat intel and user behavioral analytics tools also started misbehaving as the employees started working remotely on these new devices coming in from unknown IP. Sometimes a lot of these tools would create false positives of suspicious activity or anomalous activity. Personally, we saw with AWS Guard Duty, as people were working remotely, that we started to see dozens and hundreds of alerts starting to get fired as a result of this. This all collectively led to the meme going around as to who really led digital transformation in the company. It was definitely COVID-19 and not some C-level executive. So one of the big challenges over the past year was patch management and who should pay for data during upgrades. So a lot of administrative staff were sent home with laptops and data bundles between 3 to 5 gigabytes that were more than sufficient for the employees to do their work. However, when they needed to do updates on these devices, that is where they would run into problems, since their data allowance wouldn't be enough to cover their work and for the updates to take place. Depending on the software installed on the machines, these updates could easily total 15 to 20 gigabytes, especially finance, engineering, and design software. Many companies experienced problems with doing updates from their on-premise networks because they had policies in place which would prevent updates from taking place over VPN due to the bandwidth constraints that they had in their data centers. And sometimes the subnets needed to do the updates were also not available on the VPN, sometimes intentionally for bandwidth reasons. We also saw a lot of sys administrators were reluctant to push new GPOs over VPN connections, mainly PTSD from Windows Server 2003 and 2012, where GPOs would often fail when they were pushed over remote connections. The perimeter controls were another big issue where a lot of traffic had to be backhauled into the data center to break out to the proxies. And since a lot of large corporates have legacy network topologies where they may have multiple buildings and each building is then dedicated a set of proxies with the ability to fail over between them. However, when everybody is working remotely, this design often can fall flat. And a lot of companies had challenges dealing with internet access from their devices. One of the things that we saw with remote working is the increase in cloud adoption, where many companies used the scalability and elasticity of the cloud to address their work from home challenges. What we also saw then was a lot of cloud providers starting to have capacity constraints, especially Microsoft Azure. One of the best practices when you go through your cloud journey and as you adopt cloud is to look at workloads that can be turned off when they are not needed. This would typically be over weekends and during evenings. However, if you were to actually do that and you switched off your workloads when they were not needed and you happen to be a Microsoft Azure customer, there was a very real risk that you wouldn't be able to bring that workload up when you actually needed it. And this is a massive risk that companies needed to address, and also potentially leading to awkward situations with C-level executives when production workloads could not be brought up. So as people started working from home, we saw that the workday started to increase. A study done on 3.1 million people showed that the average workday increased by 48 minutes, something which was actually backed up by browser telemetry. So this is actually something we saw in our Microsoft Teams usage. We adopted Microsoft Teams about 2 years ago, initially moving away from Slack due to the features that Microsoft Teams had, as well as from a licensing perspective. We've seen in the data that our teams are highly effective with remote working, including working on the weekends and in the evenings, which is not ideal. One of our favorite features of Microsoft Teams is the fact that we can record meetings that then get published to stream. We host many tech sessions at our company, and being able to build a catalog of these videos as we have these meetings with very little effort is something that's very valuable to us. What we saw earlier this year was that Slack filed an antitrust lawsuit against Microsoft for the success of their Microsoft Teams product in the EU, which is ironic since Slack created a newspaper advert really embracing Microsoft Teams when the product was first announced. With all of the remote working, we saw a lot of companies embracing video conferencing and remote collaboration tools. This all led to a massive spike in bandwidth that we saw on the internet exchanges, where many internet exchanges saw a growth between 25 and 75%. Some internet exchanges saw the amount of data that they had to process doubling or even tripling in some instances. Most of this traffic was video conferencing, VoIP, entertainment, and cloud gaming related. And here's just some graphs that we saw from eKicks that really shows the increase in traffic. Many ISPs had to take action to keep their network stable. Many of these actions included moving their traffic around and prioritizing certain traffic over others, which actually goes against net neutrality rules. But they did this in order to keep their network performant and stable, something that the regulators also agreed was okay for them to do. And some of these ISPs had to trade some resilience in their network in order to gain performance to keep their users happy. With the remote working situation, a lot of companies had to embrace video conferencing, and many of them rushed to embrace Zoom. And due to their self-service platform, they really happened to be quite successful. Zoom saw their revenue double from $910 million to $1.79 billion on their last earnings call. They are seeing 300 million participants per day, with countless schools and universities around the world using their services. A lot of privacy and security flaws have been brought up by various security professionals, and one of the big problems was the issue of Zoom bombing, where teenagers or sometimes other individuals would go onto these calls and would start bombing the session through the use of profanity. Sometimes they would turn on their camera and they wouldn't have any clothes on, and this was quite a big challenge that a lot of people had. Some of the security and privacy concerns that were raised includes their false claims about end-to-end encryption, an attention tracking feature that got a lot of negative press, user data that was being sent to Facebook, no email verification on accounts, and various security flaws that could expose highly sensitive data. There was also a flaw that allowed privilege escalation on both Windows and Mac OS, and the Zoom client, when uninstalled on Mac OS, didn't remove the web server that was running on the device. Apple had to use their own services in order to go remove that web server off Mac OS devices. So as Zoom was going through this trial by fire, the Zoom CEO hired Alex Stamos, the ex-CISO of Facebook, to help run some of the security programs at Zoom. One of the first things that Alex did was he initiated a 90-day freeze period so that they could address various security vulnerabilities and privacy concerns, and only once that was done would he allow new features to be rolled out to the product. Alex was also key in the acquisition of Keybase by Zoom. Keybase had been working on their own video conferencing solution that supported end-to-end encryption, which was then incorporated into Zoom. And Zoom announced then that they would offer free end-to-end encryption to their paying customers. They received a lot of criticism over this because it was only for paying customers and they wanted everybody to get it. Eventually, Zoom caved and said that all users will get free end-to-end encryption. And they then recently rolled this out about a month ago. So end-to-end encryption is now possible with Zoom. So what we saw with the pandemic is the emergence of remote courts, hearings, and sessions. Most of them took place on Zoom. At the bottom of the slide, you can see an example of a courtroom. I believe that's a federal court. The screenshots above that is actually a YouTuber that I followed that had to close a probate deal in court. He had to share highly sensitive financial information, which was actually done over a screen share, which is one of the bad things about these remote court proceedings. However, there are many benefits, including the timing and convenience to participants, the transparency that it enables, and witness credibility, where judges can actually see the emotions better over Zoom of participants than they can sometimes in courtrooms. And in child custody cases, the first-hand home assessment that can be done by the judge is sometimes very beneficial in making a decision as to who should gain custody over a child. This all led to Zoom stock performing really well, with Zoom stock increasing by over 638%. In March, a lot of investors were buying the wrong Zoom stock, and the SEC actually had to step in and ban the other Zoom stock from being traded on the stock exchanges. One of the funny things was that these tech giants had to testify before Congress on WebEx, which is, just a terrible product, and I think it was quite frustrating for some of them. You could also see the various highly staged backgrounds, especially with Jeff Bezos. He's clearly sitting on a stage with very high quality lighting there. So one of the good things with the pandemic is that a lot of the tools for media creation, video conferencing, live streaming, and collaboration have gotten a lot better. Even when things go back to normal, this is going to be a huge win for us. In this example, I'm showing Glenn Weiss, an Emmy-winning director, directing the DNC conference remotely over Zoom. And you can also see photos of the Emmys where they sent 140 video production kits to various celebrities so that they could join remotely. Companies that have enabled and embraced remote working technologies have seen their stocks soar. Many companies saw triple-digit growth, which is very unusual in the stock market. One of the big themes of 2020 was zero trust. Now, zero trust in the past has always been tied to network isolation. However, to get the true benefit of zero trust, we need to look at how identity, context, and the state of an endpoint or device can be evaluated in order for a specific action to be allowed. And this is something that Google's BeyondCorp has been able to do. They have expanded their BeyondCorp alliance to push Zero Trust further, including announcing various partnerships over the past year. Cloudflare added additional features to Cloudflare Access, as well as announcing Cloudflare One, which merges a lot of their existing products with features that enable enterprises to push Zero Trust in a very tangible way. We also saw the announcement of HashiCorp Boundary, a new open source product to enable Zero Trust, which also merges the identity and network isolation that's needed for Zero Trust. And I'm really excited to see where this project goes over the next few years. So one of the other big themes of 2020 was phishing. As the pandemic took over, a lot of phishing kits rapidly started adopting COVID-19 lures. A lot of them claimed to be from authoritative sources, for example, government or public healthcare. A lot of these phishing campaigns were used for credential theft, identity theft, and malware and ransom deployment. Domain Tools has a list of 154,000 domains that were linked to COVID-19 phishing. Over 1,000 phishing domains were being registered per day, and often these phishing campaigns would use emotionally charged language in order to get people to click on them. And Google also announced earlier in the year that they were blocking about 18 million coronavirus scam emails per day. And these are some of the examples of the phishing emails that went around, many of them coming from authoritative sources like the World Health Organization or various public health entities. Some of these scams would claim that somebody that was close to you had been recently infected with COVID-19 and you had to take action on that. Some of these emails just plain dropped ransomware or malware onto the victim's machine. What we saw with US stimulus is that a $2 trillion care package was announced to stimulate the economy. This included funding for stimulus checks, unemployment checks, as well as help for corporations and small businesses through the SBA loans, EDL, and PPP programs. These programs were announced in a very rapid way, and banks were not ready to take on these new applications, and scammers quickly took advantage of the confusion and lack of preparation and started scamming and phishing campaigns regarding these various loan programs. As a result of the scams, millions were handed out to scammers. In a report compiled by the SBA, some companies also applied for multiple loans in other companies' names, and one company was actually caught applying for 85 loans, which they were actually granted. What we also saw is a rapid increase in fraud in healthcare procurement. There's a really good example where someone actually tweeted Donald Trump around ventilators. Donald Trump had one of his team members reach out to this person, and this person scammed New York out of $69.1 million, where 1,450 ventilators were meant to be delivered at 3 times the market rate, but no ventilators were ever delivered. An additional $355 million was spent on medical equipment and PPE. Most of this funding went to companies who were not in the healthcare business, including high-end fashion brands, Chinese iron ore and tool importers, personal hygiene companies, and oil companies. Now, it should be mentioned that some of these companies had good intentions of actually trying to help the company through the pandemic, but some of them merely saw it as a cash grab. One of the threats that also started emerging was phishing. What scammers would start to do is look for new employees that were joining companies through LinkedIn, and then they would either pretend to be the new employees and call the IT team to get their credentials, or the scammers were pretending to be from IT and called these new employees to get their credentials out of them. And this happened to both Bank of America as well as AT&T and Verizon, as well as GitHub. So the next theme that we'll have a look at is online game cheating. In previous years, I've spoken about the emergence of online game cheating, and it's definitely not a new phenomenon. There have been a myriad of talks in the early 2000s at DEF CON about online game cheating. A lot of these cheats often use tooling to manipulate memory and pointers to give the players that use them an unfair advantage. This often allows players to be invisible to other players, get unlimited ammo, currency or health, to change their positions or to jump around opponents, to shoot or see through walls, to create bullets that appear out of nowhere, as well as to get aiming assistance. As I spoke about last year, there was a massive increase in online game cheating, especially with the Fortnite World Cup that took place, where over 1,200 players were banned for cheating. And with the lockdowns in place, many turned to online games for entertainment, resulting in record-breaking numbers of online users. Steam actually broke its concurrent number of users multiple times over the past year. One of the things that started occurring as esports tournaments went remote, a lot of servers experienced DDoS attacks, leading to a huge amount of frustration amongst pro players. So as these DDoS attacks started to take place, tournament organizers had to come up with new ways on how to deal with the problem. A lot of them started to stream gameplay after it had taken place. This had the unfortunate side effect which affected the gambling part and betting part of the tournament. A lot of these tournaments had over $100,000 in prize money who could predict various brackets correctly. And a lot of these results for the games that had taken place, ranking websites were publishing the results before the game had been streamed, allowing bettors to place bets knowing the result before the game was actually officially streamed, which a lot of people found unfair. What was very funny though was to see some of the resistance to this online game cheating. A YouTuber called ScriptKid decided to take revenge and created a fake set of cheats which people downloaded. He marketed this through Google Ads, and what would happen, a cheater who was using the software during the game, this fake software would randomly hand out punishments to the players that were using it, including dropping bombs and mollies, shooting their teammates, randomly starting to spin. There were trigger points on certain maps so that players will jump off the map. Some players would drop their guns, and in some cases it would play a sound effect when the player shoots, but it wouldn't actually pull the trigger of the weapon. What we also saw is the UK National Crime Agency taking out adverts to dissuade teenagers from buying stressor or DDoS services. In research published by Cambridge, it actually showed that there was a remarkable decrease through these campaigns, which I think is quite an interesting initiative. So one of the big concerns over the past year was, with the rise of the pandemic, was that healthcare started to come under attack. Pharmaceutical companies started investing a large amount of money into vaccine research. There's over 100 vaccines currently in development, and these are different types of vaccines, including sterilizing vaccines and functional immunity vaccines that work in different ways. And what I've done is I've highlighted some of the most prominent vaccine candidates. We have the 2 candidates from Russia, as well as a number of other countries, including Moderna from the USA, the combined effort between the University of Oxford and AstraZeneca from the UK, Pfizer and BioNTech from the USA, Johnson & Johnson and Emerging Biosolutions from the USA, and Novavax also from the USA. And some of these vaccines are currently being tested in country. We know from earlier this week that the Pfizer vaccine has an efficacy rate of 90%, which is unheard of. Most influenza type vaccines like the flu shot typically have an efficacy rate of between 50 and 60%. One of the things that we know at the moment is no matter who is first to market, there will be a supply constraint. Various pharmaceutical companies have mentioned that they'll be able to manufacture between 20 and 50 million vials of the vaccine and about 1 billion vials each respectively next year. One of the challenges with the mRNA vaccines like the Pfizer and Moderna vaccine is that they need to be transported at very low temperatures, and a lot of logistics chains cannot actually handle that. As we have seen with the vaccine development, we've also seen a massive rise in the attacks against these pharmaceutical companies, resulting in the NCSC and CSER issuing a joint statement about these attacks from nation-state actors. You can imagine on the global stage, various nations want to be the first to have a vaccine and thus have issued tasking to their intelligence agencies to get this information, especially information relating to the vaccine itself and how it's produced, so that if they need to get any ingredients, they are able to do that. Some of the most common forms of these attacks were spear phishing campaigns, password spraying with credential stuffing, as well as exploitation of known vulnerabilities on various systems and devices. DHS published a list of 25 vulnerabilities which are the most exploited by nation-state actors, for example, Chinese APT28. And I think it's shameful that 8 of these vulnerabilities are security products. So nation-state actors are exploiting vulnerabilities in software and hardware which is meant to keep an organization safe, yet they are being used as an vector in order to break into a company. So we saw charges being filed against Chinese state actors. They are alleged to have broken into a number of companies around the world across various industries, and they are also have been alleged to have broken into some companies to steal COVID-19 research. So what we started to see was a rise in ransomware attacks that were targeted at hospitals. A patient died in a German hospital after they were hit with ransomware. His treatment was delayed, which resulted in him passing away. Many ransomware gangs actually came out quite publicly saying that they won't attack hospitals. However, many attacks still took place across Europe, the UK, US, and other countries as well. And this led obviously to a slew of jokes that if you attack a US hospital, that's a very good way to get vanned or droned. So the next theme was contact tracing. So as the virus started to spread, people wanted to start linking infections between people, and they did this typically through forms and surveys. The survey that I'm showing you here is the survey that you need to complete if you travel internationally. However, many of these forms were hosted on websites or were using products where the data, potentially sensitive data, was not actually wasn't secured properly. So many contact tracing solutions were proposed, which mainly fell into 2 categories: a decentralized approach and a centralized approach. One of the big challenges with this was how to collect these tokens in a privacy preserving way. Apple and Google formed a joint initiative to work on a privacy-preserving contact tracing solution together, and they did this through their Exposure API, which is compatible on both of their platforms. The system relies on cryptography to ensure that maximum privacy is attained. The system works by broadcasting a random ID from the person's device, which also then collects these various IDs of other devices that it interacts with and records the time and distance between them. If a user tests positive for COVID-19 or is unwell, they can flag themselves with a token which is then uploaded to the service. Various user devices then download these tokens and look for other tokens that they may have interacted with. If the token matches, the app calculates a risk score and then lets the user know that they should probably be tested because they have come into contact with an infected person. Some of the challenges around the contact tracing solution was concerns around how trolls may abuse the reporting functions in the various apps. In a centralized approach, the collection of sensitive data such as location data could be misused for other purposes not related to contact tracing. And as contact tracing started to happen, contact tracers started calling people, letting them know that they had come into contact with somebody that was infected. However, there was no way of knowing if you were actually speaking to a legitimate contact tracer, something which various scammers took advantage of to extract sensitive data out of people, especially the elderly. There was also an interesting fail where 16,000 COVID cases went unreported in the UK because officials exceeded the Excel spreadsheet limit. So next is malware and ransomware. In 2019, we saw an increasing sophistication of threat capabilities with many exploits using multi-stage attacks. Emotet and Trickbot still remain some of the most commonly found and deployed malware currently. The number of malware families have actually decreased over the past year, but there has been a significant increase in ransomware attacks. One of the interesting trends is that attacks are actually now starting to be staged. So what ransomware gangs would do is they would infect an organization using droppers in malware, and they would wait until multiple people had been infected before actually triggering the ransomware to actually encrypt data. This way they can actually encrypt a lot of data before an incident response team would be able to isolate it. And a lot of incident response playbooks assume that one device gets infected at a time. However, it would be quite a problem if multiple devices started encrypting files at the same time. And adware and spyware is still a big problem. So the way that Emotet typically works is it would send malicious attachments through mail spam, and these emails typically contain a malicious Office document or a link to a malicious Office file that users are told to download onto their PCs. So the way that this would work is someone would get a file, they would open it, there would be macros in the document, they would then open it and enable macros, and then the malware would execute and would infect the machine. One of the things that we saw back in 2018 was that when Emotet infected a system, it would go download a number of other malware families as well. One of them was Trickbot, which is a banking Trojan, which would steal credentials off system by harvesting emails and by using Mimikatz. However, at the beginning of this year, we started to see that Emotet would only deliver Trickbot. And this time Trickbot wasn't just a banking Trojan, it was also dropping ransomware in many cases. And there was an interesting case where a vigilante was actually sabotaging the Emotet botnet by replacing a lot of the malware payloads with GIFs. Now, a lot of these malware payloads are actually stored on hacked WordPress sites, and these temporary hosting locations are actually the Achilles heel of Emotet. So it was interesting to see this happening. And with the US elections, there was growing concern that the Trickbot botnet would be used to interfere with US elections. So we saw action taken by Cyber Command and Microsoft to take down the Trickbot botnet. Microsoft used copyright and trademark law to disable 120 of the 128 known command and control servers. This took out 94% of the Trickbot infrastructure. What we also saw was an unusual move by the NSA to drop a report on new Linux malware that they had found from the Russian GRU APT28, otherwise known as Fancy Bear. The malware is called rover, which is seen as the cream of the crop with regards to Linux malware. It is seen as the Swiss Army knife for hacking into Linux because it provides full privilege backdoor access to Linux systems. We also saw some action from Microsoft where they removed 18 Azure AD apps that were being used by Chinese state-sponsored hackers. We also saw in October that charges were filed against 6 Russian military intelligence officers for intrusion into multiple computer systems around the world. This included attacks against the Olympics, the French elections, and attacks against the Ukraine government and infrastructure. They are also alleged to be behind the global NotPetya ransomware campaign. We also saw charges being filed against the Chinese attackers from the company Chengdu 404, otherwise known as APT41. This company provided pen testing and other white hat type security services. However, they are alleged to have participated in state-sponsored attacks, including attacks in the United States, France, Japan, Singapore, and South Korea. In a rare instance, we actually started to see Russian businesses also getting attacked with ransomware. Now, it's an unofficial rule in the cyber underground world to not attack former Soviet space. In fact, a lot of ransomware malware will actually check whether they are in a CIS country. These are countries that are formerly part of the Soviet Union, which includes Belarus, Ukraine, Kazakhstan, and Uzbekistan. And what would happen is the malware would check the time zone, location, and country that it was in. And if it found itself in one of these countries, the malware actually wouldn't infect the computer that it was on. One of the leading theories is that whoever's behind this ransomware campaign actually lives in one of the CIS countries but doesn't live in Russia and is actually trying to use this to get back at Russia in some way, but that's just a theory at this point in time. So one of the big ransomware attacks that took place over the past year was the attack on Garmin. The attack started on the 23rd of July and knocked out a whole bunch of their services, including fitness tracking services, customer support, and commercial aviation offerings. There are conflicting reports about exactly what ransomware family was used. However, it is believed that the Tridex malware was used to deliver the Wasted Locker ransomware into the environment. The initial infection mechanism was a drive-by compromise where it is alleged that somebody downloaded a fake file or potentially for a browser, and this then triggered the ransomware to execute in the environment. Garmin paid a $10 million ransomware. Garmin paid a $10 million ransom, either directly or indirectly through a third party, and in doing so violated US sanctions. So after this happened, the Office of Foreign Assets and Control in the US issued a statement effectively banning ransomware payments to these sanctioned entities, which includes EvilCorp, CryptoLocker, WannaCry, and Samsung. These, if a company pays a ransom, they can face both civil and criminal penalties up to $1 million and 20 years in prison. But will sanctions really work? I don't believe that they will. Making something illegal hasn't stopped it from happening. If we just look at corruption, tax evasion, and the drug war, making something illegal really hasn't stopped it from happening. And we need to look at the case of paying for ransom versus the case against paying for ransom. Now, if a company finds itself in a situation where all of its data and systems are encrypted and its business depends on having that data and systems available, it could potentially go out of business, which would lead to a loss of tax revenue for the state and a loss of jobs. And if a payment is made under duress, that is under the threat of life, there's an interesting self-defense argument that could be made. Since a corporation is a separate legal entity, it has similar rights to a person. Therefore, if it is threatened, it has the right to self-defense. And that could be an interesting legal argument to be made in court. And this could potentially lead to jury sympathy if a jury trial occurs for criminal charges. However, they would argue that payments may lead to additional attacks taking place, the potential national security risk, and that the people that are behind these attacks may actually use the funding to continue their campaigns against other companies. Another big theme of 2020 was the insider threat. So earlier this year, we saw a number of Twitter accounts getting compromised. So on the 15th of July, a number of accounts were compromised and messages were posted directing people to pay Bitcoin started to appear. Initially, these tweets contained a URL which contained instructions on where to send Bitcoin. Once that site was taken down, these attackers pivoted to tweeting out the Bitcoin address where Bitcoin should be sent. You know, if you send me some Bitcoin, I'll send you double in return. And popular accounts such as Jeff Bezos, Bill Gates, Kanye West, Elon Musk, Apple, and Uber, amongst many others, were targeted. When this happened, I initially thought that this was the result of some kind of third-party breach. At the beginning of the year, we saw a number of NFL teams' Twitter accounts getting compromised because they were using a third-party social media analytics company whose infrastructure was compromised, and that infrastructure was then used to take over these various Twitter accounts. However, it actually turned out that a number of Twitter employees were actually social engineered, and that access that they managed to gain through the social engineering was used to gain access to their systems. Twitter had a tool where people could go read other. So Twitter had an internal tool that would allow their internal staff members to read other people's data, including performing functions like password resets. The password to this internal tool was actually published on a Slack channel, which these attackers managed to gain access to. And as part of the attacks, over 130 Twitter accounts were targeted with these tweets. 8 accounts had their data downloaded from Twitter, and this resulted in 426 Bitcoin transfers were processed to the address mentioned in the tweets, and that totaled around 13 Bitcoins, with a total value of $117,000. And I think given the enormity of this situation, I think $117,000 is really peanuts. There could have been much worse things happening with the access that was gained through this tool. The way that the attackers were found is that a joint investigation by the FBI, Secret Service, and IRS was conducted, and the FBI used its copy of the OG users forum database, which had been hijacked by a rival firm a few months before, and by combining that data with some chat logs, they managed to track down Graham Clark, who was 17 at the time. He's the main accused or the mastermind behind these attacks. Graham was already known to law enforcement because he had participated in various SIM swapping activities and had accrued over $1 million and was living by himself in an apartment in Florida. He was granted bail of $725,000. His co-conspirators were charged. It's unclear at this point whether Graham will be charged as a minor or as an adult. So one of the other insider threats that occurred was the attack on Tesla, where a Russian citizen had migrated to the US and was working legally for Tesla in their Nevada factory. Then another Russian citizen approached this Russian migrant with an offer of $1 million to plant ransomware onto Tesla's network, which would be done directly through a USB drive. And when this attack took place, the ransomware gang would perform a DDoS attack against Tesla to distract the security team while the ransomware was actually running. However, the employee went to management after this had happened. Tesla called in the FBI, and this employee with the FBI then set up a sting operation where this person was arrested and has now subsequently been charged. Another big theme of 2020 was disinformation. So 2020 was really a train wreck of issues. We had a global pandemic, a US elections, mass global protests around racism, police brutality, and climate change really led itself to becoming a melting pot of issues which could be used to spread misinformation and disinformation. What we've seen with disinformation since the 2016 election is that the number of pages and accounts spreading disinformation has increased sharply. Typically, these disinformation campaigns are often created by nation-state actors, mainly to interfere with the politics of other countries. However, increasingly, some of this disinformation is actually being created by other groups with other interests, and not just governments. In 2016, we know from the Malware report how Russia used advertising to spread information, and it's easy to think that this disinformation pandemic is only, or the infodemic is only related to the US. However, there are many other countries that are being targeted as well. In Myanmar, the government used Facebook and Instagram to share highly inflammatory messages. A lot of the content used emotional imagery to spark an emotional response by those who see it. Many of these accounts will post popular content and celebrity gossip to build audiences. Once they have an audience, they will then start sharing political messages. What you also start to see is that a lot of these accounts share information in a highly coordinated way, and these pages then start building very significant audiences as they go with this. We also see a common tactic where pages will steal photos and profile photos from other users and pages tracking the links between all of these domains can be quite a hard thing to do. And there's a number of researchers that have been tracking the links between all of the domains. Not only can this be quite difficult, but it can be quite helpful to link domains and the actors that are behind them. What we started to see as well with the US elections is the rise of information operations. So we saw information operations from Russia, China and Iran trying to interfere with the US election. What we saw Russia doing was they created a website called Peace Data, where they used freelance journalists to write stories and then published them using fake names and accounts. These accounts were then created using fake profile photos which were generated using artificial intelligence. And another website called the Newsroom for American and European based citizens was also created, and once this came to the attention of the various social media platforms, these accounts were suspended and links to these websites were also prohibited from being shared. We also saw the story about Biden's secret emails, which is actually a story planted by Russian officials against Rudy Giuliani. What we also saw previously is that QAnon likes to spread conspiracy theories. They have subsequently been declared a domestic terrorism threat. Previously, we saw conspiracies including human trafficking rings, alleged criminal activities, and anti-vax movements. These conspiracies have led to people committing real-world crimes such as shootings and kidnappings with the belief that they are actually helping the cause. And one of these crimes included an innocent person who was portrayed as a mob boss who was completely innocent, but then was gunned down by somebody that believed in the conspiracy. And with the global pandemic, a lot of the conspiracies are centered around COVID-19. So here was just some examples of campaigns that we saw from Mexico and Spain against US elections. And again, these campaigns would often use popular images for engagement and other content to appear authentic. So social media platforms got a lot of criticism from the 2016 US elections. They have been quite decisive in 2020 against taking actions against these disinformation campaigns. One of the things that they also did was they started placing labels on misleading content. For example, the election fraud allegations made by Donald Trump started to see labels being put on that it was misleading, as well as other tweets that were claiming the same thing. One of the consequences of all of this disinformation is that some of these conspiracy theories, for example, the 5G conspiracy theory that alleged that 5G infrastructure was led to the spread of the coronavirus, led to some people in the UK actually setting cell phone towers alight, even though some of them were not actually 5G towers. And the UK is treating this as a national security threat because not everybody has broadband access and relies on these towers, as well as a lot of these towers support the ESN network, which is used by first responders. And one of the big concerns that I have over the next year is that we're going to see a lot of disinformation and misinformation around COVID-19. And sometimes it's not always intentional. If we look at this example from the Washington Post, depending on what Twitter client you had, you may have gotten a different version of this article. So if you only read the tweet, you would have thought that the Oxford vaccine had killed somebody. Whereas if you actually saw the tweet with the headline, you would have seen that the person who died actually didn't get the vaccine. They got a placebo and not the real vaccine. Thus, there shouldn't be anything to be concerned about. So next up is the WeChat and TikTok ban. So TikTok has seen unprecedented growth over the past 4 years. In 2004, it took Facebook a year to get 1 million users. In the same time period, TikTok had managed to amass over 100 million users and has made its Chinese parent company ByteDance one of the most valuable companies in the world. As TikTok became very popular, a lot of rhetoric started to be thrown around regarding the privacy implications of TikTok. There have been many posts claiming that user data is being harvested so the Chinese government can use it in various nefarious ways. And this is despite the fact that many other social media apps like Facebook, Reddit, Twitter, LinkedIn and Instagram collect the same amount of data, and in some cases even more data than TikTok is collecting. And yes, the Chinese national intelligence law is often cited as one of the big concerns with TikTok. So TikTok has grown very quickly in India before protests demanded that TikTok be banned so that local apps can grow. India has since banned several other Chinese apps, including WeChat. These privacy concerns have led to many companies banning TikTok from their devices, and this includes the US military branches. Donald Trump has spread a lot of disinformation around TikTok and has tried to use the CIFAS and IEPA laws to ban both TikTok and WeChat from the US. There's a lot of legal action currently going on about this. It's unclear why this is the case, but it seems that this is linked to his trade war against China. And TikTok users also sabotaged the attendance on one of his rallies by registering that they would attend, but then obviously not actually going to the event. And this may have upset Trump to a certain degree. I don't normally use memes in my presentations, but I thought this one to be quite funny, which says, if you want to steal my data, you have to be a US-based corporation. And one of the arguments for the WeChat ban is that US interests need to be looked after, and if TikTok is a growing company, that is a non-US company and should be stopped. So one of the conditions for TikTok to continue working in the US is that some of the operations need to be taken over by a US company, and TikTok has by a US company, and Oracle has agreed to be TikTok's official technology partner, which spawned a lot of jokes about Oracle Cloud gets its first customer, and also the fact that Donald Trump is the Oracle Cloud salesperson of the year. And what also then came out was that Oracle's Larry Ellison had actually donated $250,000 to Lindsey Graham's super PAC days before the TikTok deal went through, which obviously is no big surprise there. The next theme that I would like to talk about is satellite security. So a large part of the world's population lacks access to high-speed internet, something which the pandemic really demonstrated. And in order to solve this, SpaceX is planning to have 12,000 satellites in low Earth orbit within the next 6 to 9 years, with plans for further expansion up to 42,000 satellites in the future. Currently, SpaceX can manufacture and launch 60 satellites every 2 weeks, but this does bring up an interesting question around what would the network of the future potentially look like? Are satellites potentially going to be the new network edge in the future? And because these satellites are in low Earth orbit, they can actually achieve lower latencies than some of the fiber optic cables today. So if we look at the latency between London and Johannesburg, currently on fiber that's about 90 seconds, where on satellite that could be as low as 77 milliseconds. This obviously depends quite heavily on weather conditions. So as part of the Starlink program, it has seen 15 launches, with 13 of those launches taking place this year, which has delivered 895 satellites into orbit. It has been amazing to see how quickly SpaceX has been able to launch these rockets. In the past, you would only typically see a handful of launches every year, and as an av geek, it's really great to see how fast they are being able to launch these rockets. So far this year, we've already seen 21 launches and only 2 failed landing attempts. In June, there were a total of 4 launches. We had the NASA Crew Demo 2 mission, and then 2 Starlink missions, and then a GPS mission followed after that. And on the day of this conference, the first official crew mission from NASA will actually be launching late in the evening. So satellite security is not something that has seen a lot of attention in the past, something which the Aerospace Village at DEF CON wanted to change, and they hosted a Hackersat contest with a prize of $50,000. So qualification rounds took place, after which teams had to complete several challenges. So teams were given their own flat sat to test code on. There was a room where the satellites were orbiting inside the room, and these flat sats were sitting in a carousel and were sitting on air-supported bearings so that the attitude control systems could keep the satellite in the right orientation. So these flat sats were running a core flight system that was developed by NASA, and the winning team managed to run their code on a real-world satellite, which is alleged to be the EraCube 10B satellite, which was launched in 2019. So moving on to the last theme of the year, which is around encryption. So last year we saw 90% of the internet is encrypted. That's up to 95% today. We know from the certificate transparency logs that last year we had over 1 billion valid certificates, which was quite a milestone. However, the number of valid certificates has now declined to 700 million. It's unclear whether the pandemic had any impact in this. Maybe people stopped creating certificates for their Kubernetes containers. We also saw certificate issuance start to increase. So in 2018, we saw 700,000 certificates being issued per day. That increased to 2.9 million certificates that were being issued per day. We saw that increase in 2020 to 4.9 million certificates being issued per day. This means that the issuance rate has increased to 193,000 certificates per hour. From a market share perspective, Let's Encrypt has increased its market share to 78%, with Citigo, formerly Komodo, dropping down to 10%. What we also saw is the increased adoption of elliptic curve cryptography. So from 2018 it was 7%, 2019 10%, and in 2020 it's up to 17%. However, due to the rapid growth between 2018 and 2019, even though percentage-wise it only increased by 3%, it actually saw a 5-fold increase in the number of certificates. Unfortunately, many cloud services still don't support elliptic curve yet. We did see an interesting crypto bug being reported by the NSA in the Windows Crypto API DLL, which validates elliptic curve cryptography certificates, which would allow an attacker to perform a man-in-the-middle attack. In closing, I would like to make some predictions for 2021. I mentioned earlier on, I think we're going to see a huge amount of COVID-19 vaccine disinformation. As budgets tighten with the economic situation that we have, as security spend will decrease. This will lead to larger and more complex ransomware attacks. We'll continue to see advancements in zero trust tooling and software. We'll see an increase in data breaches from manufacturers and retailers. We'll see TLS 1.3 bugs and other crypto bugs. Attackers will focus their attention on attacking the home. We'll see the continued misuse of deepfakes and other AI. We'll see the increased adoption of cyber insurance, and we'll see attacks and misconfigurations of SAML infrastructure. And that is the end of my presentation. Thank you very much.
Well, hi there, everyone, and thanks for attending my talk. My name is Charles Roth. I go by Angus Reid, and today we're talking about open source intelligence, the gateway drug your mother never told you about. Right, so the outline of my talk today, I'll give a brief introduction to myself. We'll then talk about what is OSINT, why we do OSINT, sort of why it is awesome, the highs we get from that, the side effects, what you can gain indirectly, whether you continue down a sort of a professional line of OSINT or just stop there and move on with your life. And then we'll talk about feeding the supply. And then we can take some questions afterwards. I'll be on the Discord if you need me. All right, it's a brief introduction. As I said, my name is Charles Roth. I'm a lead technical security recruiter. I recruit predominantly in the United States, do a little bit in the EU and the UK, and then also dabble some stuff here in South Africa. I'm former British Airborne, and I did about 6 years in higher security consulting, predominantly in East and West Africa, and then also some time in the Middle East. Locally and in the community, I'm involved with a fair amount of conferences. I'm a co-organizer with B-Sides Cape Town. I'm the founder of HackSouth, along with some very great people, and I'm an avid open source intelligence analyst. Shout out to Cryptic, Monks, and Devet for the third place in the recent Trace Labs, which I'll discuss momentarily. Right, so what is open source intelligence? Okay, so taken from Wikipedia, I'll read directly. It says open source intelligence is a multi-method, qualitative and quantitative methodology for collecting, analyzing, and making decisions about data accessible in publicly available sources to be used in an intelligence context. In the intelligence community, the term open refers to overt, publicly available sources as opposed to covert, clandestine sources. It is not related to open source software or collective intelligence. Okay, so open source intelligence under one name or another has been around for hundreds of years. With the advent of instant communications and rapid information transfer, a great deal of actionable and predictive intelligence can now be obtained from public unclassified sources. Right, so typically the sources will include media, like print media, magazines, radio, television, the internet, which is the predominance of what I do now, will be, your Facebooks, your LinkedIn, Twitters, Instagrams, blogs, message boards, anything sort of in that sphere. Public government data, especially in South Africa, is quite readily accessible. Looking at birth records, death records, property records, that sort of stuff, anything that the government will push out. Also, CIPC is quite helpful here in South Africa. Professional academic publications, which is not so widely used, but is still viable. An example I can use of that is if I typically want to know something about someone in this industry that's given a few talks, I'll typically watch the first 4 or 5 minutes of their talk to hear the introduction, to see how they introduce themselves, and I'll take information from that. Next up, we have commercial data, which I don't use that much, which includes, like I said here, commercial imagery, financial industrial assessments, and databases, hopefully legally acquired databases. Grey literature, something I'm not very familiar with. This includes things like says here, technical reports, preprints, patents, that sort of stuff. And it says here at the end, open source intelligence is distinguished from research in that it applies the process of intelligence to create tailored knowledge supportive of a specific decision by a specific individual group. Right, so this is directly pulled from Wikipedia. Okay, so why OSINT? What do I and what do we use it for? Right, so on the fun side, CTFs. So these are usually based on fake information with fake accounts in order to test someone's ability to gather intelligence and piece it together to form a hypothesis. Examples of this, such as hack the box challenges, I've done a fair few of them. A friend of mine, Bushido, he also spoke at a recent con I was at, Conent. He's got 1 or 2 really fun challenges to do that's got like a storyline to it. And then on Twitter, you also get things like hashtag OSINT challenge, which is trying to identify the location of where a photo was taken, literally just from a picture or from a Google Maps screenshot. Right, so typically your challenge looks like this. So this is on Hack the Box. So you'll see here, super secure startups, private information is leaked. Can you find out how? There'll be a file to download. Now, typically what you would do with this is you would look for information related to the company, super secure startup. You would try find them on LinkedIn, try find them on Twitter. You'll see sort of where the path takes you. You'll see who's engaging with who messages who. And from that, you basically pull a password that unlocks this document and then gives you the flag. It's quite fun, but can be quite challenging on Hack the Box. Right, so the OSINT challenge that I mentioned, this is one example. So you got Jock Smith here. I recently went on holiday about 3-4 weeks ago on the way to Picanesekloof. So I took a photo while I was driving, or while I was in the passenger seat, of course. Took a photo and then said, try find me. And you see here's the picture that I took on the left, and on the right is directly pulled from Google, where he had used the mountains in the background, route markers, and then a house on the road to identify exactly where the photo was taken. And he was pretty much bang on. Right, so the next thing is TraceLabs. So TraceLabs is a CTF based on it says 8 to 12. It can be like the recent one, 5 to 12 missing persons cases. It is the same as Hack the Box. I is there to challenge your ability in open source intelligence, but with TraceLabs, it is based on real people and real cases, and so it has a real outcome. So with TraceLabs, intelligence is sought on cases. We submit that, we get points for the things if they're validated, and then all that intelligence that we gather is then given to law enforcement. Very often we do find the locations of people, or find locations within the last couple of days of where someone was, despite them being missing for hundreds, even if not thousands of days. Right, really fun, really good to do, and like I said, it has a real outcome at the end of it. So that's what it looks like when you do well. So this is from our recent third place with TraceLabs, and this is a meme that Big LDP from TMHC made for us, where we came 7th in the one before last. It was a very, very, very close competition. Right. So another use for open source intelligence is red teaming and social engineering. So many red teamers will use open source intelligence to gather intel on proposed targets. They'll use that information to build a picture on their clients in order to exploit vulnerabilities such as the human factor using social engineering and other exploitation tactics. Okay, so this usually is forms part of the recon phase. So you get, a big name, a red teamer like Jason E. Street. He did a talk once at, I think, at DEF CON or DerbyCon, where he mentions that he would do open source intelligence, but to be fair to every client, he would only start scratching around to see who, what, and where people are. I think he said only an hour before an engagement, or maybe the day before an engagement. So, so that everyone is given equal opportunity to get owned. But yeah, this forms part of the recon phase. Okay, so an indirect use, and something that I actually want to do a talk about one day, is the indirect use. So things like property investment. So a straight example, I was looking at buying a property last year, buying something that's lowballed, and then doing a fixer-upper project. I found a really nice house on a 2,000 square property in Moreesburg, a small farmer's town. I wanted to understand as to why the house was R500,000, but it was 2,500 square property. I then did some intelligence. I looked up I've learned now that I need to find the ERF number, the ARF number. Once I found the ARF number, I looked at SWAT-line departments records that they post every 2-3 years on property valuations. So when they bring up their rates, through that I could find the name of the owner. I can then do some further intelligence, and I quickly found out what was going on at the house, who owns the house, what activities go on, and I quickly realized, if I buy this house, I'm going to have a lot of dramas, probably a lot of debt collectors coming in, and probably a lot of people looking for some stuff they shouldn't at 2 in the morning. So, I made a adverse decision to not invest in that property. Okay, so business development. So, as a recruiter, I do extensive open source intelligence to understand my clients or potential clients, what makes them tick, and how to string pieces of information together to execute a better pitch. So it's important to understand. If you are a name brand company that most people know about, I will know about it, and I wouldn't really have to do that much scratching. It's all about just finding an in. So with companies that I don't know so well, but I know potentially are doing some interesting stuff, I will do some basic open source intelligence. I'll conduct basic research on the target and the people I know and know them. I'll build a picture of the company and the people I want to contact, execute an outreach using some basic info to help break the ice and build familiarity. I'm ex-British Army, so if I find someone in the company that's ex-Army or ex-British Army, I will try go down that avenue to try break the ice, try build some familiarity, and then from there, I will attempt to do, a sort of a soft proposal to see if I can work with that company. I think some people see this as business intelligence, which it is to some extent, but it's just another use for the skill set. Right, interview prep. This is actually, it turns out I was doing open source intelligence a long time before I knew it was called OSINT. So doing open source intelligence for interview prep is really, really valuable. So as an interviewer, as an interviewee, it's good to get information on the company that you're interviewing with so that you can show them that you have an interest and you have done your research. So typically that'll be try understanding where the company operates, where the headquarters are, what they do, maybe understanding if there's any bad press involved with the company, what kind of people work there, see if you know any people there. This kind of stuff will tend to help you get a job. When a company will always ask you, so what do you know about us, right? And that's your chance to say, I know you folks operate here, here, here. You do this, that, and the other. I actually realize I have 2 friends that work for you folks down in Joburg and Durban. So you'll kind of give that information until the company says like, hey, that's cool, thanks. We appreciate you did your research, but it ticks that big box that shows that you have an interest in the company. And hopefully you get a job from that. Right, so candidate vetting, this is something I was asked from the last conference, like how deep will I do this? So when I would use open source intelligence to do candidate vetting, it happens on a very rare occasion. It is only if I have a sixth sense about them or a strange inkling as to them there being a risk involved with this candidate and their background and their history and maybe trouble with the law. It's happened a few times. I've spoken to people in the US, and it turns out they have federal indictments. We all make mistakes, but it's important to have that information before you send someone to a company. So, also if you think someone's, you can't not hire someone based on their beliefs or what they do on the weekend, but it's good to have that kind of information before the time. It's important to reiterate, me in recruiting, I have done this literally a handful of times. It's not something I have to do very often. Okay, so the drug. So why is it so awesome? Right, so it's important to understand the ease of entry. So what it takes to do open source intelligence or to be able to conduct it effectively. Right, so let's look at what we require. Okay, so these are the prerequisites, right? So ideally you need a computer or a smartphone. If you're smart, you can use a computer with a VM, as I typically use. But if you needed some basic stuff, a standard computer or a smartphone will do. Okay, you need access to the internet, as that's going to be where you find the majority of your information. Okay, curiosity. You have to have some sense of curiosity. If you like watching murder mysteries on Netflix and stuff like that, it means you have that curiosity to go out and find stuff. Next is understanding the rules of engagement. So the typical rules of engagement to keep safe is what we call zero touch. So it means you will never engage or interact with any form of intelligence that you find. If you find an Instagram profile, you will not follow that profile, even if you have a SOC account. You never want that to come back to you and your sort of your data being tagged to that person's profile, and then they end up being murdered, you know? So the rule is always zero touch. Never get involved and never use your own personal profiles in order to do intelligence. Okay, understanding what you want as an outcome. So it's important in intelligence, and I guess with most things in life, it's important to understand what you're trying to get out of this. Like what needs to be the end result. Like with the property stuff, I wanted to find out, honestly, I wanted to find out what the circumstances were with that house, to see if I could make a lower offer. The house was actually on the market for $950, and I want to see if I can offer $500. Turns out the mortgage was in duress. Right, so it's important to understand what you're trying to get out of it, so as you go down your path with open source intelligence, and you find a bit of int here and there, and you branch off from that central line, i.e. away from the target into family and friends. If it's not taking you towards that end result, then you kind of will shut down that branch and come back to your main line. Okay, and understanding what you might find. So this can include things of sexual or graphic nature. It can include violence. If you're investigating, underage children, you have to mentally prepare yourself for what you might find. Typically, you're going to find the edgy stuff on the dark web. I have zero experience working on the dark web, but you have to be prepared for what you might find. Having all these in place means you're pretty much good to go. You see, not like this. That's not, you think it's complex, but it's actually, you can see how simple it is, right? And that it's open to anyone. And part of this talk and this journey is getting people that might not be involved in InfoSec or even technology to see how easy something like this is, as a start to a journey towards information security. Okay, so what is the result? Okay, so this is now the satisfaction that comes from doing good open source intelligence, right? Okay, so the find. So finding that last known location of a missing person and reading an article, knowing that you were perhaps part of finding that person, there's a lot of good vibes that come from that. It's like popping a box on something. It brings a sense of joy and excitement and satisfaction to you. Okay, so getting that new client and getting that new job. So you did your research, you got a good in with a company, and you managed to land them. That's always going to be good vibes and good feelings, right? Or if you're researching into a company, you impressed a company, maybe you impressed them well on the technical side, quite as much as they expected, but you smashed them knowing so much about that company and what that company does. Okay, so when you know, you know. When you know, you know. When you sharpen your abilities, you know what you're able to find and what help you can provide and how to protect yourself, your friends, and your family. By having a deep level understanding of how open source intelligence work and how you take small piece of information, string it together, equips you better for making better decisions and helping protect your family and your friends when posting stupid stuff on things like Facebook and Instagram. There's a sense of satisfaction in having that understanding. Okay, many pieces make one pretty puzzle. So with open source intelligence, you'll find a bunch of small pieces of insignificant intelligence, right? When you get all those small pieces together, you can build an interesting picture and you can understand what was going on. With Trace Labs, we'll look at an underage girl. Say now she's 16 and been missing for 400 days. You'll look and you'll find her Facebook profile where she's connected with all her friends and family and everything looked fine and there's a lot of smiles, a lot of happiness. And then you find their sock accounts, so their alternative accounts. Sometimes they'll have more than one. I've found people that have 10 alternate Facebook accounts. And then you see the beast within. You see the drugs, you see the gang affiliations, you see the tragic circumstances at the house. You quickly get a better understanding of what potentially led up to this person going missing or what led to the situation. So yeah, those small pieces of information, they mean nothing. But when you put them all together, it builds a fascinating picture. So knowledge. So the knowledge of knowing, when you have a skill set, you know what you're able to find and how to achieve something. Right? It's like with anything in life. When you have that understanding, you know what you can achieve with it. You know how you can use that skill set to bring goodness into life or achieve something in life. There's great value in that. Okay, so side effects. So what can you gain indirectly from having a skill set in open source intelligence? Okay, so side effects. Okay, so being a champion of open of OPSEC, right? Operational security or PERSEC, personal security, right? So being a champion of operational security and being, you know, the family OPSEC troll, you know, typically people in our industry have a very good awareness and understanding, and we tend to be trolls with our friends and family and say, hey, like, be careful posting this, and this is why you shouldn't post that, and stop doing those surveys on Facebook. Having this understanding will help you, you know, protect your friends and family more, and you know, being, like I said, you're a champion of OPSEC. Okay, so the hunger. So you had a taste and you want more. Due to the ease of entry of open source intelligence and then achieving some success, it is only natural to want more, whether it is more OSINT, whether it is more OSINT, or whether it is just more challenges, right? So from the hunger, you might fall into the part where you build some form of intent. So once achieving the above, one starts to learn more about security and how to find other information on hacking, right? So although the next step is more technically challenging, the hunger and the intent is enough to push people into this direction, right? So that's what happened with me when I started exploring this industry more from a personal perspective. I started with OSINT and I loved it. And from OSINT, I started doing CTFs, and I thought, hang on, let me try something else. And I did forensics, and I enjoyed that. So that's why I said it's like a gateway drug. It starts you off down a vicious path. Okay, so the path. So once you've had the drug, you built the hunger and have the intent, people tend to build a path in line with security, right? Not everyone, but some people, right? I evolved from open source intelligence into forensics challenges, and from there into more Jeopardy style CTFs. And then I got into Stego and some offensive stuff at obviously an extremely basic level, and at a very slow pace. From there, you know, formal plans evolve into things like pen testing, red teaming, social engineering, and forensics, like it did with me, right? So this can lead down to, you know, potentially a changing career. You know, you're that IT person or that dev that suddenly had an interest in this. You took a swing at Trace Labs or at some challenges, and you enjoyed what you did there, and then you evolve into something new. So now with everything you've learned, you have added many other skills, and you are doing more technical work. But all the while, you're using OSINT in its many forms to add value to your new and evolved career. Okay, so feed the supply. This will make sense shortly. All right, so going clean. So, you know, this is now, you know, you tried OSINT, you maybe did Trace Labs, you did some challenges, and you're just like, well, you know, this is dull, this is boring. You know, if you're an offensive security specialist, OSINT probably not going to be as exciting for you, right? You prefer to, you know, sit behind a command line and do all your Gucci stuff, right? But, you know, at least there's some stuff you can take from it, right? So you gave it a shot, you tried, and perhaps it's just not for you, and that's cool, right? You still gained, you know, no matter how in depth you went, you still gained a lot of experience and understanding in operational security and personal security, and that's always of value. You've gained a different level of mindfulness by understanding the risks and how information can be strung together. You know, it'll help you be better equipped to make better decisions related to what you post and push out on the internet, ideally. And, you know, if not any of that, you can just remember the good old days. You know, if I start doing OSINT now, I would always think about it. I always think about that one case where we found this and we found that. I have some very fond memories from the recent CTF we did, where we managed to track down very managed to track down a location of someone that'd been missing for almost a year and a half. And those build memories. And it's like, get your first shell one day. You tend to remember that. Shout out, I got my first shell thanks to Toko. That's on Hack South. Okay, so you decided to continue down your path with OSINT. So you didn't give up like the previous slide. You decided, where else can this go, right? So you can go show and tell, right? Tell your friends and tell your family about what you do and how it will help them take better care when they're posting information, right? So my missus, this talk somehow inspired her, and she's now starting to learn more about open intelligence. Right, by telling your friends and family, you not only make them aware, but who knows, maybe some of them might have an interest in doing this because of its ease of entry. Right, so keep that in mind. Right, understanding the entry is now, getting involved. It took a lot from me to take on an OSINT challenge on Hack the Box, which then led me to Trace Labs, which led me on to more diverse CTFs. All this has led me in a direction of a career change. So I hope, yes, I'm in recruiting now, but I hope to be a digital forensics consultant one day, or do cyber threat intelligence or something down that line. Right, by understanding the ease of entry, you may be more inclined to take your first shot or challenge a CTF. Right, so it took me touching OSINT to want to dip my toes into things like Jeopardy style CTFs. Because everyone else was doing stuff, I smashed all the OSINT challenges, and I was like, you know what? Let's look at forensics. And once I solved one forensics challenge, thanks to Google, I was like, I can do forensics, and let me learn more about this, and let me see take it. And that's now evolved into a complete career change. All right, so the evolution. So walk the path that OSINT takes you. It might lead you to just being more mindful and more aware, which could lead you down a path into information security. Right, so takeaway and summary. Right, get involved with open source intelligence in whatever form. You're probably doing it already. If we just like, if you're dating online, you're always going to try find information to find out if they're crazy or not, right? A lot of us are doing it without being aware. Maybe this talk just helps you label that, and that's fine. But see where it takes you and try it out. Come join us on Hack South and do some challenges on Hack the Box. Come join us for Trace Labs. There's no more challenges this year, but next year I plan to win it, and I will win it. Right, so come join us. I know like the vet that's on here, he works in the legal space. He has very little understanding about information security, but he built an interest in OSINT, and he took part with us, and me and him have done well with that. With him and the rest of the teammates, with him I've come seventh and third globally with Trace Labs. So don't be adverse to walking down that path. Right, if you're scared, remind yourself of the ease of entry and take a swing. So this talk might not necessarily be that well catered to advanced offensive security people, but it's there to help inspire everyone and have a try at it, like we try other challenges on a CTF that we have no understanding of. Right, it's a new skill to learn. Okay, remember the rules of engagement. Remember, zero touch. Try use stock accounts or alternative accounts. Use a VPN. Try stay as secure as you can, and be mindful of that which you might find along the path. As I said earlier, tell your friends, tell your family, and tell your colleagues about open source intelligence. Some people love it. It's good. Sometimes at a braai, it's a pretty good conversation starter in showing people what you can find of them. Doing a typical thing like asking someone's email address or scratching around trying to find the email address. You find the email address, you put in have I been pwned, and then you explain to them, what it means when their email address has been in like 4 different breaches, which is something I had recently happen at a braai. Taking all that can show people how vulnerable they are, and it'll make them more mindful, and also it might interest them. And what better way to defend yourself than upskill and learn from the best. Okay, follow the path that OSINT takes you. Whether it takes you down just a simple doing the CTF side, or whether it takes you down a path into information security, see where it takes you and follow that road. Right, if you like it, keep learning and evolve your skills. I am very good at basic OSINT. I don't use any tools really. And that's discounting things like a VM and SOC accounts. There's a lot of good tools out there, and that's what I plan to use to sharpen my skills. But it's pretty straightforward stuff. You just got to understand what to look at and what paths to walk down, right? And if you evolve with that, you can get better and you can evolve into other new things. Yeah, and as I said, yeah, learn new things. So I am trying to work. I'm not very good at geospatial intelligence. So finding places on a map, I'm really bad at that. But I'm trying to work on that. So one thing I'm focusing on now is getting better at triangulating where a photo is taken, and trying to identify where a location is purely based on a photo. So yeah, learn new things, and this is typical of this industry. We're always required to learn fun and interesting new things. Right, links and attributions. The only thing I took out here was from Wikipedia, and obviously there's a lot of Giphy GIFs on here. Right. So quick one about HackSouth. Obviously, it's a server that we're hosting the con on this year. Please be sure to follow us on Twitter. We're on LinkedIn as well. If you want any cool roles, we've got a bunch of reaction roles. If you got a role assignment, you can get some new stuff there. And come join our team on CTF time. This is actually the list of the CTFs we've done so far this year. So as you can see, we're quite active. There's usually the usual faces in the CTFs, but we'd love to have more people join us. Thanks. I'll take some questions on Discord. And here are my socials. Thank you very much.
Good morning everyone. So I'm glad to say I'm doing another HexCon talk. We're doing it slightly differently this year, meaning we're not getting beers afterwards. But I do have a pretty slick view of the ocean from here, so I'm not complaining too much. So what we're going to be looking at is code reuse and software that wasn't specifically made to be reused. So it's not an API, it's closed source. But we want to look at the functionality that this uses, right? So in the past, if we wanted to do this, we had to painstakingly reverse engineer the code, re-implement it in our own way, right? The alternative was we had to rip it out of where it was, including all of its dependencies, which is extremely time consuming. So a bit of an intro for what I do. I'm just some random security guy. I've dabbled in everything in InfoSec you can think of. I've done pen testing, red teaming. I do a lot of automation detection, a little bit of threat hunting, and product reviews as well, right? So I'll take different systems, hook them together, and automate away all the tedious parts of incident response. Every now and again, I get to play with some malware, which is easily my favorite part of it. But this doesn't happen nearly as often as I'd prefer. So what are we going to be doing, right? So most of the malware I see does the same thing over and over. It unpacks, decrypts, and ejects. So I'm guessing the reason for this is that malware that doesn't take the time to hide itself isn't going to make it upstream to where I'm going to catch it. It's going to get filtered out by mail servers. Antiviruses are going to catch it pretty quickly. So anything commodity, I'm not going to see. And then the things that I do see has a fair bit of work that went into it. So we have to dig into the PE file format if we actually want to work with these samples. So the PE file format has the .exe extension, which is what we all know it as, right? So unfortunately, there's no shortcuts here. We do have to know how this PE file format works for a lot of for incident response, malware analysis, and for what we're going to be doing today. So why do we need to know what this format looks like? So we have to find the malware, especially if it's been injected into another process, for example. We have to know what memory should and shouldn't look like. We want to be able to instantly spot from a memory dump what is malicious, right? Often we have to extract and rebuild it. So if something is injected into a process, we have to convert it back to an exe on disk. The reason we have to do this is it's incredibly hard to work on malware in a running state. The problem is we're going to rename functions, create comments, whatever the case may be, but as soon as that application stops running, all of this information disappears. So the Windows loader does a pretty good job at putting the executable in memory for us, right? The problem is if it's already there, we can't, or the Windows loader can't reverse it for us. And also we can do some pretty clever things if we know how this works. So specifically in this case, we're going to be looking at code reuse. So I have done some work in this in the past. 4 years ago in my HexCon talk, I released a tool called Cryptomnesia. So this tool took little pieces of malware, ripped them out of the original sample, and allowed you to mix and match afterwards. So you could create this Frankencode piece of malware that's specifically what I was aiming for, made attribution a lot harder. So for example, even though a threat actor has been known to use a specific piece of code, we now have malware that contains code from multiple threat actors. So it's not easy to know who actually created it. So the CIA did do some work in this. If you look at the Vault 7 leaks, which released a bunch of operational manuals from the CIA, they have looked at this, but it's not clear if they actually use it in practice. So instead of using code in this way maliciously, we're going to turn it around. We're going to take malicious code and use it for good, right? We want to minimize the reversing in this as much as possible. So the old approach was extremely time intensive, but especially during an incident, we are not going to have time to do it. So we want to minimize that. So how do we actually do it, right? The problem is the PE file format is extremely complex. It has probably upwards of 50 data structures, all doing different things. And we have to parse all of these, or at least all of the ones that are applicable to what we're doing. Unfortunately, there's no shortcuts, like I said earlier. So I initially put off learning how this works for quite a while. You're going to come back to it. There's no way that on this level, the malware you're looking at is not going to make use of these features, right? So like I said, incredibly complex, but we're going to skip through most of it and only look at the specific data structures we need. So we are lucky in that a lot of decent documentation is available for this file format. We've got nice little diagrams like these which make it easy to digest, as easy as it can be at least. So we're only going to be looking at 8 of these little blocks for what we're doing. And we're only going to slightly touch on what they actually do. So we're lucky in that there's a lot of tooling that helps us complete all of these analysis phases. We've got PE parsers that will show us specific fields in the EXE, like time, date, stamps, checksums, whatever the case may be. So the popular one is CFF Explorer, which I'm going to be using. We've got PPEE, pronounced puppy, and PE Insider. Those are the 3 big ones. When we want to figure out what the code actually does when we're reverse engineering it, we're going to need debuggers like IDA Pro, which is a commercial one, which I'm using. X64 Debug and WinDebug, these are both free and incredibly powerful tools. For quick prototyping, we're going to be using scripting languages like Python, and Python specifically has a library called PEFile. So what PEFile does, it allows us to extract information from an exe file in readable format, but it doesn't allow us to modify anything. In fact, modifying an exe after it's been compiled is extremely difficult. Any small change can mess up these data structures and it might not load, it might not function, or whatever the case may be. So this might be a bit of an information dump, but let's dig into it, right? So an exe starts with 2 bytes, MZ. So this stands for Mark Zabowski. He's one of the early Microsoft employees, and he is responsible for at least a part of this this file format and all the data structures it contains. So as a malware analyst, what you see fairly often is 4D5A, right, in hex. So these 2 bytes are the same as MZ, and whenever you see these bytes in a location you don't expect it, which is pretty much everywhere, you are virtually guaranteed that something malicious is going on. Similarly, you might see these 2 bytes base64 encoded, which is pretty common, and then it's TFQQ, right? So if we look at the DOS header, that's the first little stub in this. We only care about the MZ header and the last 4 bytes of the DOS stub, which tells us the location of the NT header. So you can see between these data structures, we've got this little program that says this program cannot be run in DOS mode. That is actually a 16-bit application. So if you run one of these executables in DOS, it's going to run that little code stub, and it doesn't execute the actual 32-bit or 64-bit code. After the little DOS stub, you can see there's a bunch of data. So Microsoft, for some reason, uses this as a convenient place to store additional stuff. Even though it's part of the 16-bit application, it doesn't get executed. The program executes before. So one example is the rich headers, which gives details about the specific compiler used. And you have things like delayed imports, which hardly ever gets used, but that gets chucked in there as well. So if we look at our second data structure, we've got the NT header. So the NT header contains 2 other data structures. We've got the file header and the optional header, right? So the file header includes a lot of exe specific fields. So it has an architecture entry, which tells us is it a 32-bit or 64-bit application, right? We've got our timestamp, when it was compiled, number of sections. So a section is a specific block of memory that contains some of these data structures. And then we've got characteristics. For example, is it an exe, is it a DLL, and loads of other things, right? So as a malware analyst, these fields are extremely useful, right? So a user is not going to see these fields. For example, if you right click on an exe, go to information and look at that info, right? It could tell you the version of the application and whatnot. This is actually in the manifest. So that is a text file in the resource section. So this information doesn't get showed to the user. The manifest information gets showed. So one nice example of this is when Stuxnet was first discovered in 2010. Researchers started looking at similar strains of the same implant, right? And one of the fields they were looking at is the timestamp field. That allowed them to create a timeline for exactly how Stuxnet progressed, how it was updated, and so forth, right? So when they published this information, the NSA caught on really quickly, and they blanked out this timestamp field. One mistake they made, though, is there's 2 additional timestamp fields in the exe. You've got the export directory and the resource directory. They both have timestamp fields, and they didn't blank these out. So researchers kept doing what they're doing, and they managed to link Stuxnet back all the way to 2006. So this was a major operation, right? Anything that goes on for 4 years has got some proper backing, and that was another indication that this was a nation-state attack. So as a malware analyst, a lot of these fields are going to be interesting to us, even though an end user might not see it. So if we look at our third data structure, we've got the optional header, which isn't optional, so the name is a bit misleading. But it has entries like the image base, which is where the application prefers to be loaded. The application entry points are the first commands that are going to be executed in the file. This is never at the beginning of the file, it's somewhere in the middle. We have our section alignment, which tells us on what memory boundary our sections are going to be aligned. Our file alignment, which does the same thing for data on disk. Checksums, which tells us if a file's been modified, and a lot of event file. I think there's about 50 or more, or some such. So if we look at our next data structure, we've got our data directories. So these are entries that all link to other data structures, right? So if we have sections that are specifically for example, for resources, we've got our resource section, and then we have our resource directory entry. This tells the Windows loader where to go look for resource information. So resources are going to include images, pictures, icons, mouse pointers, whatever the case may be. So all of these data structures that are linked to are incredibly complex as well, so we're not going to dig into these. What we do care about specifically is the import and export directories. So firstly, we have to look at our section headers, right? So our section headers tell us where a specific block of memory is going to be. They all have their own permissions, and they're all used for different things. So by convention, for example, you have a .text section. This is where your code is stored. You've got .data, which is where your read-write data is stored, and loads of others. So this section tells us where this is placed in memory, how big it is in memory, where it's on disk, how big it is on disk, and all of the permissions associated with that section. So going back to our import directory, this is going to have a directory entry pointing to wherever it is. And what the Windows loader does with this is it tells it, or the application tells the Windows loader what functions it needs in other DLLs, what the DLL's name is, and the Windows loader will go fetch those and map it into our process for us. If we go look at our export directory, this is similar, just in reverse. So our application is going to tell the Windows loader we're exporting specific addresses, be it variables or functions, so other applications can use the code that we provide. So this is generally what DLLs do. There's no rule that says this has to be a DLL. You can have exports and EXEs as well, though that is not standard, and your code has to be slightly different if this is what you're doing. So what happens in the export directory is you can have, let's say, 10 exports. So these are memory addresses that's going to be used by something. You can either reference these by name or by ordinal, which is just a number. So you've got 3 parallel arrays in this case. So let's say we have in the last array we've got 5 entries. They all have a name. If we want to look at where these addresses are, we're going to take the specific index. So let's say index number 1, which is going to be some function name. We're going to look up that index in the address of names array, which is going to give us an ordinal number. We're going to look up that ordinal number in the address of functions, and that's going to give us the function address, which the Windows loader is going to use to actually map the name to the location for where it is on file, right? So lastly, looking at the loading process. So Windows is going to, or the Windows loader is going to pass all of these data structures for us, and it's going to map the exe into memory. So your memory alignment is normally 1000 hex, while your file alignment is 200 hex. So it's almost always the case that your executable on disk is going to be smaller than your executable in memory. So that is also one of the reasons why when we have a piece of malware, we can't just rip it out of memory. We have to understand how this file format works. We have to go read and encode it, so when we do run it for analysis, the Windows loader knows how to load it for us. What we also want to look at is the import address table. So I mentioned that the loader needs to know which functions and DLLs to load. And to give an example of this, let's say our program needs to use the internet function, so to fetch something from a website or whatever the case may be. It's going to have an entry that says, please load this specific DLL and give me access to these functions. The Windows loader is going to map those addresses back into our application, and our application doesn't have to know how this happened. It just has access to these functions automatically. The reverse is, if we expose specific functions, some application is going to do this process. The Windows loader is going to pass our code. It's going to look at the export directory, look at where these functions are, and map those addresses back into the process that requested access to it. And then also there's loads of other things going on. The loading process is extremely complex, but luckily for us, we don't actually have to look at how these work for now. So I know this is a lot of information to take in. I said we're also lucky in that we have tools that can do this for us. We've got great documentation for the most part, and we only have to look at a fraction of what these structures actually contain. You're going to be constantly looking up these fields, so you don't have to know them off by heart, and I end up looking at the documentation over and over when I'm working with these. So at this point, what do we know, right? What conclusion do we have? Is By looking at the data structures within these files, we can modify them to create exports. We can take a specific piece of code in malware and tell the Windows loader that we want to have access to this piece of code. So it's not going to run the entire thing. It's going to only run pieces of code when we want to use them. So there's a couple of reasons why we want to do it in this case. So one example is a lot of malware actually encrypts its configuration. So the standard for actually looking at these files, or the common approach, is to reverse engineer it and go create a decryptor as a malware analyst. So this is extremely time consuming. We want to make it easier, right? So we can, for example, create an export entry for the function that decrypts this information. We load this as a library, we call this function, and instantly we have the decrypted config without having to reverse engineer or recode this. Another example is I've seen malware that doesn't do a good job at its crypto implementation. So all it does is it actually decrypts and encrypts with the same key, but you have to, for example, pay a ransom before it will do it, right? What we can do is go hook or create export entries for the decrypt function, just call it ourselves, and the malware will decrypt our files without us actually having to pay a ransom for it. And then specifically what we're going to be looking is disrupting C2 channels. So if we have a piece of malware, we can see it's calling out to some site. We want to be able to disrupt this channel so that all the implants calling out to the sites can't actually be used by the attacker, and hopefully we can disrupt this server that they're using completely to make it unusable. So why do we actually want to take this approach, right? So the one problem we're having at the moment is that we have a lot of users working from home. They're not sitting behind the corporate firewall anymore, so where we could have previously just blocked something on a firewall, we no longer have that option. Another problem is that even when you identify malicious C2 hosts, hosting providers don't take them down, and this is a pretty big problem for us. So we've identified an attack. We know maybe some of our users are infected. We don't know how many, but we can't do anything about it. So I was thinking we can possibly do this by ourselves. So let's see if we can disrupt these channels without help from the hosting provider. So I did get a little bit of pushback when I started this research. Basically, it was an ethics debate on hacking back, right, which you've had back and forth a lot of times, especially on Twitter. So if you are being attacked, is it okay to attack back, right, to disrupt this channel? Generally, you're not allowed to mess with infrastructure you don't own, and in this case, we do not own this infrastructure, as I said. So you can also make the argument, if we do disrupt them, what are they going to do? Report us, right? So this is a victimless crime, but you still have people arguing back and forth. This is not a settled debate. So for this, I'm going to choose a easy or a common target, right? So what I'm going to be targeting is called Cobalt Strike. It's a commercial product. It's about 55,000 Rand per year for one license. And it is incredibly powerful. The problem with this tool is, although it's a commercial tool, a lot of APT actors are using it actively. So we've got, for example, the Lazarus Group, which is North Korea. We've got Charming Kitten, which is Iran. And they are known to use this framework quite extensively, even though the US doesn't export to these countries because of the Wasana agreement. So presumably these licenses that they're using are cracked versions of the product, but the fact is they're still using these to attack us, so we do need to know actually how to defend ourselves against it. So Cobalt Strike has a large list of extremely powerful features. For example, you can do pivots to reach hard to get to targets. You can dump password hashes, grab screenshots, whatever you can think of. It's extremely extensive. What's especially nice about this tool is the customization we have over what our traffic looks like. So Cobalt Strike names this malleable C2, and it allows us to tailor our network traffic to what incident responders are going to expect to see. So for example, the screenshot is Cobalt Strike set up to make the C2 traffic look like an image that's being downloaded. As an incident responder, when you see this, you're not going to be concerned. It looks legitimate, where in fact it's how this implant is communicating with the command and control server. So this is incredibly complex, especially from a code perspective. If you want to interact with this server yourself, traditionally you would have to go reverse engineer all of this code, write your own parser, write your own generator. But we do not have time for this, right? Especially if we're in the middle of an incident, it's chaos. We have to figure out where we're exposed, if we're exposed, and we want to minimize this process as much as we can. So Cobalt Strike uses a reflective DLL, which has been modified to be position independent, right? So what this means is the author has the possibility of writing this implant in normal C, but it can still be injected into memory as position independent. We don't need the Windows loader to load this for us, which, as I said previously, when we're analyzing malware is a problem because we need it on disk. So all of the standard loaders that come with Cobalt Strike are injectors, so we can't just use it as is. So in this case, I needed to go create a simple wrapper for it, which allows us to run it from disk. It doesn't inject into a new section, and any comments we make, functions we rename, we can keep those and continue our analysis. In this case, because all of the configurations for Cobalt Strike are stored within the sample itself, we do need a valid sample of the implant that the attacker is using against us. So going to the hard part, I said we don't want to reverse engineer this entire thing. Unfortunately, we do have to at least know how it works. So we don't have to know how it does something, only that it does something and what it's doing, right? So this is a screenshot of me debugging Cobalt Strike when I was creating this framework. So if you look at the second little block I highlighted, that's the function that initializes auto communication channels. So this didn't have a name in the beginning, I named it. And to identify what it was doing, I just looked at the code. It was calling a lot of internet function setup code, but it didn't actually do anything with it. So chances are this is just a setup function, and in our code we're going to need to call this before we do anything else, right? So what I did is I took all of these functions or variables and I gave them names. So this is a tool I created called PEPewPew, and it'll take a malicious implant, craft a new export directory for it, and give it the names that we specify. So luckily, to check into the C2 server, we don't need to reverse a lot of the application, and the existing code will do all the heavy lifting for us. So if you look at this, this is a screenshot of CFF Explorer, which I mentioned earlier, which is a PE file parser. This shows us the export directory for the implant that I modified. We now have access to all of these functions, which are the ones I named, and we can use this implant, which was traditionally a standalone application, as an API basically. We can create code that runs these functions even though the main implant is not going to be running. So this does all the heavy lifting. Instead of us having to go look at how the C2 functions work, we can just tell this implant, here's a piece of data, go send it off to the server. I don't care how you do it, just do it. So where we previously would have to code thousands of lines of code to mimic this behavior, I've done it in under 100 just by using the code that's already there. So there's a lot of ways we can actually disrupt these C2 channels. We can, for example, let's say we check in 100 malicious clients, 100 implants into a malicious server a second. We're going to make this server completely unusable. I took a different approach. I decided I'm going to show some ASCII text. So the attacker, while they're using this framework, they first have to look at my pictures, and secondly, I'm going to make this server unusable for them. So even though our users might be exposed, they're still going to be infected. The server they're calling back to is going to be unusable. So because Cobalt Strike actually has a client limit, For one, we're going to stop additional beacons from calling back to the server, and hopefully we clutter the server's UI with so much information that it's not useful anymore for the systems that are infected and are successfully calling back to the server. So this brings us back to the debate. Should we actually do this, right? The problem is, if you think about it, what are we going to do instead? We've got infected hosts. We can't necessarily reach them. Some of the protection controls have been disabled by the users, which we see occasionally, and we have to protect the network from this threat. So luckily we've not been in this scenario, but I suspect I'll lean to one of these two when it does come to actually protecting the systems in these ways. So PEPPU is a research project that I've actually implemented a bunch of different attacks into. So one of the other features, I'm not going to be showing these, but you can look at the source code, play with them yourselves. It's DLL proxying, sideloading, and hijacking. So what this does is it allows us to craft, for example, a DLL that's when it gets, or when the application, a valid application, requests the DLL from the Windows loader, our DLL is going to be loaded instead, and instead of returning or performing some operation like the application expects, we're going to do something else. One example of this is again Stuxnet. The Stuxnet hooked the DLLs that return telemetry from the centrifuges. So instead of the centrifuge saying something is wrong, which was the case, the DLL changed this message saying everything is in line, and when these devices started falling over and spinning themselves off their axis, the technicians looked at the analysis, the software said everything was fine, and they didn't actually know what the problem was. Another one I've implemented is just jumbling the import directories. So what a lot of antivirus engines do is they create a hash of the import entries. So they call it an imp hash. So if a malware author changes his code to look different to evade AVs, the input hash is not actually going to change because he didn't change the functionality. So AVs can now find multiple strains of the same malware just by looking at the import hash if they found one specific sample. So in this case, like I said before, the input address table is extremely difficult to modify, but it's possible to jumble some things around, which then changes the hash, which is what I did in this case. There's also some other features, like for example, changing the debug directories, which also causes antivirus engines to treat your sample differently. And my main research on this case has been basically how antivirus engines handle malware. So there's a lot of room for improvement. There's a lot of things it can do already, and you are more than welcome to go play with these, give me feedback. I'd love to implement some new features if you can think of them, and we can see where this project goes, right? So at least now we are in a position to perform these actions. We can possibly disrupt C2 channels. It's still up for debate if we should be doing this, but we have the option now. I'd love to take this project a bit further, speak to you guys about it. I'm going to be on Discord, so please look me up. We can chat about it, and we can see where the project goes. But I hope you enjoy the rest of your HexCon, and we'll probably look at this again in the future, so look out for it.
So what kind of mark do you want to leave behind? I've got a story that might inspire you. It starts 40,000 years ago in a cave inside a mountain in the northern part of Spain called El Castillo. And if you look at the roof of this cave and you look a little bit closer, you'll see some marks up there, some artworks. And it might surprise many of you to realize that scientists are now beginning to agree that this specific piece of art was not created by humans. That's right, look again, count the fingers, and it's not what you're thinking. These were created by Neanderthals, or Neanderthals to use the correct pronunciation. And Neanderthals went extinct about 40,000 years ago, but notice how different they are to us. Look how much bigger their brains were like us. And if you could entertain me for a moment, if we wanted to write Nick Bostrom ancestor simulation, and imagine we did this in Java, we would create an abstract class called Homo heidelbergensis. Notice that the genes are private. And we would then extend that class to create a Neanderthal. Same thing for Homo sapiens, and our UML diagram would look something like this, and then 500,000 years later we'd add on Homo sapiens. So the two are quite different in that if we created an instance of a Neanderthal and an instance of a human being, Neanderthal does not equal human being, nor does human being equal Neanderthal. But they were a separate and intelligent species that lived on Earth many thousands of years ago. And, interesting unrelated side fact, humans could shag Neanderthals, and this did in fact happen, which leads me to my theory around where these handprints got onto that cave wall in the first place. But back to the point. Neanderthals implement a make-mark interface as well, and so do we. And this is what it looked like for Neanderthals, and we have our own versions of that. So back in the present day, I'd like to ask you how you want to implement your make-mark interface. This is a completely different type of cave painting. It's called the Pioneer plaque, attached to the Pioneer probes 10 and 11. And while these were being constructed, pay attention to where that dish is being mounted on those struts, and if you had to peer between those, that's where you'd find the Pioneer plaque. It's funny to me that they're actually pointed facing inward and not outward. But anyway, these were the first probes that humans sent outside of our solar system, past the orbit of Mars and past the asteroid belt. And Jupiter was one of the first planets that Pioneer 10 visited, showing us a photograph like this, which, maybe a story for another day, wasn't actually taken with a camera. But it's a misconception that Pioneers 10 and 11 used an Intel 404 chip. They actually had custom TTL logic, and that custom TTL logic could only handle about 200 instructions, with memory to handle about 5 in advance that could be sent from Earth, with approximately 40K or 50K worth of memory. So a very interesting mark that was left there. Later on, these were sent out. You might recognize these as the golden records used on Voyagers 1 and 2 in 1972, and this is from NASA's JPL website. It's a very cool 3D model that you can interact with, and it shows you exactly where they're mounted on these probes, so you can see exactly where they are. A little bit bigger than normal records, but if you wanted to play one of these, fortunately the instructions are on the cover on the front. So for anyone or anything encountering these, they'd first need to understand that there's a property of hydrogen where the state of the spin moments between the proton and the electron changes, and this can be used as a universal clock. If you match that up to give you the rate of rotation at which you should create your own record player to play this with, you can then be able to pick up the signals off that record and compose an image. And notice that calibration image, that circle down in the bottom. This is what it would look like or sound like if someone had to actually play that record. And there you've got that calibration image coming in. Very interesting stuff. And here's an image of our galaxy and what it looks like. This is what our number system looks like. And it carries on like this with pictures of various things from all over the planet. A lot of it is copywritten, so I can't show you a lot of it. And as usual, there's always some human genitalia attached to many of these things. That's why I'm barred by this conference's ethics and rules to be able to show you the rest. But there are also other interesting things like how we communicate with radio telescopes, and I especially love this picture of the Arecibo telescope. Here's a nice view of it from above, because when this was inaugurated in the 1970s, they sent out this very famous Arecibo message, and I raised this only because this had a fun little joke reply that came back called the Arecibo reply, which I thought was pretty funny. But anyway, the Voyager probes also had their own type of computer. They had three, in fact. The main one being a command control computer system. And this is what uplinked and managed all the procedures between all other types of computers. Again, this was custom TTL logic running at 2 megahertz, but it had about 64 kilobytes of RAM and approximately 64 megabytes of storage. And this is what the CCS looked like from the outside, some black and white photo curves from the inside. And it was actually dual core. It had two processors, notice processor A and processor B. And notice as well that it wasn't actually any type of flash storage, but actually tape. It had 1,000 feet of 8-track tape that it used to store images and other data that it would later on relay back to Earth in a very slow connection of 168 bytes per second going up and 72K coming down. Now the probe was programmed in a custom sort of assembly language that used 18-bit words with 6-bit opcode and 12-bit addresses. There were only 13 registers in total, and some of the software for high-level functions was written in Fortran and later on ported over to C. So of course we're not talking about Doom 2016 or Doom Eternal, and we're not talking about Doom 3 either. We're talking about the original Doom from 1993, and I'm sure a lot of you guys are asking yourselves, but why? And that's because Doom really is special, because Doom was impossible. If you think of the best computer hardware you could buy for yourself at the time, this is an example of a Onyx by Silicon Graphics that could cost you anywhere between $100,000 and $200,000. And in 1995, a computer like that was used to develop Toy Story the movie, which required 117 Sun Microsystem computers in racks like this, 800,000 machine hours, to render 114,000 frames of animation that all looked like this. Compare that to what Toy Story 4 looked like last year, and look at the detail on that. You really do get a sense of why, at the time, Doom really was before its time in pretty much every possible way. So, I mean, if you think about what Doom looks like and what you could get 2 years before Toy Story even came out, in real time, on a computer that wasn't even designed to produce 3D graphics like this, it really is amazing. I mean, consider you could run this on, well, at an absolute minimum, an Intel 386 clocked at 33 megahertz and only 4 megabytes of RAM. There was no need for a graphics card, and they didn't even exist, not even in their first versions. That's what things like Quake ended up encouraging in the market. For most people, this is what computers looked like, and this is what Microsoft Word looked like. So way back in February 1992, some of the first Doom alphas were released. So some of you may never have seen these. This is what the main menu looked like. There's this weird heads-up display. This is this kind of space marine base and a weird bayonet attached to the front of this gun. And on the 10th of December 1983, on our Software Creations BBS, 2.39 megabytes of data was uploaded to a University of Wisconsin-Madison server. And it's a myth that the server actually crashed. What really happened is that so many people were expecting Doom that it had filled up the entire connection pool for the FTP server, and they had to phone the admin up to go and restart the server so that the guys at id could actually get a connection and upload Doom. But after that happened, everyone started playing Doom, and it was a major success. It started earning id Software $100,000 a month. John Carmack and John Romero both bought themselves matching Ferraris, and multiplayer became this huge thing, although back then the term deathmatch was of course coined, and this was the deathmatch manager. And I remember using this with a serial cable to connect my computer to family members or to friends to play deathmatch games, which I spent way too much time doing. And at least things didn't get too much out of control, but there were articles like this in things like PC Magazine, where Doom took over my life. It makes one think of World of Warcraft, actually. But it's absolutely true that Doom was banned in places like Intel, Lotus Software, and many universities. And by 1995, there were over 10 million installations of Doom. meaning that there were more installations of Doom than there were of Windows 95, which was one of the things that prompted Bill Gates to make this very strange promotional video promoting Doom 95, which was meant in turn to promote Windows 95 as a gaming platform. But of course, It Runs Doom became this massive phenomenon, and I love this comic where this computer scientist is talking about this alien computer that has an architecture entirely foreign to ours. We have much to learn from it, and we may have much to fear. And the computer scientist saying, bam, I've got Doom running on this thing. And this trend is so much fun. This is Doom running on an iPad, Doom running on a Canon printer, Doom running on an Apple Watch, but don't worry, Android fans, we've got you covered. Doom running on the touch bar of a MacBook Pro, Doom on a Kodak digital camera, Doom on a PSP, Doom on an ATM machine, Doom on an oscilloscope, Doom on a barcode reader, Doom on the entertainment system of a Porsche 911 Turbo, and Doom on a toaster. I think those last two were probably fake. But are you convinced that there must be something about this software that makes it easy to port and just something worth looking into and something worth learning about? And this is why I'm proposing that Doom might just be the ideal candidate to leave on a rover like Curiosities, especially because the story of Doom starts on Mars, and it's probably also as much of a cultural artifact of how we got to this point over the last couple of decades than anything else. So at this point, it's probably a good idea to introduce some reference material, and a lot of what I'll be talking about today is based on two books. First, the Game Engine Black Book for Doom by Fabian Sandglad, and this goes into a lot of the detail around how the code was put together and how various different parts of the game engine worked. So that's really, really recommended, and if you're interested in other titles by Fabian, like his books on Doom 3 or Quake, I'd highly, highly recommend those. But I've used this extensively as reference for what I'm going to be chatting about today. And then from a more cultural story about how Doom came about, Masters of Doom by David Kushner is a very, very good read. And by the way, if you do grab the audiobook version of this, it is read by none other than Wesley Crusher. So, who made Doom? id Software were these guys who actually started working in this lake house, first developing Commander Keen and then moving on through other titles like Wolfenstein and Doom. And the two main characters we'll read about in this story are both John Romero and John Carmack, neither of whom came from, wealthy families with grand houses. They actually came from broken homes and didn't have fancy educations. But looking at John Romero, he was the principal artistic influence on the game, I suppose, and a lot of the development around the level editors and level designs and those kinds of things, where John Carmack was really the brains behind the development of the engine that ran Doom. So he was developer squared and created the 3D engine and really wasn't shy in using a lot of reference material and academic papers to get the maths right behind what he wanted his engine to be able to do. So in 1983, the Nintendo NES came out, which, by the way, can also run Doom if you make some very serious modifications to one of the cartridges and put a Raspberry Pi in it. But the NES was most popular for running games like Mario. And I just want you to notice how the background can move as Mario moves here. That was something quite unique to consoles at the time. And even 7 years later, in 1990, the PC, for example, running a game like Prince of Persia, just notice how, while Prince of Persia was fun, you probably never noticed that the background never moved, because it was very expensive for a PC to redraw the background every single time. And that's why they looked like this, and why most PC games look like this. But enter on the PC Commander Keen in 1990, and there's a VGA version of it. And if you play this game and start a new game, this is what it looked like. And notice we have a moving background, and you need to understand that this was quite revolutionary for the time. No other PC games could do anything like this, and this is what id Software was able to do. But how did it work? Well, if you take your normal screen resolution for a PC of the time, you only had 320 by 200 pixels to deal with, and every time you as a programmer wanted to write a piece of software that would render a game like this, you needed to render the entire screen, put it in VRAM for it to go out to the display, and then for every frame you'd have to redraw the whole screen, pop it in VRAM. Same thing, you get the idea. This is not terribly efficient and why it generally wasn't done. Enter adaptive tile refresh, which was a VRAM hack, an EGA-based VRAM hack, where you'd put the whole image into VRAM and then just reference it by its XY coordinates to be able to move it around on screen as follows, and thus you could get this kind of gameplay. So by 1992, Wolfenstein 3D comes in, and here's just a little bit of video of how this thing looked. I love that get psych thing. Let's go start a new game there, bring it on. Love that loading screen. And you'll see a lot of common elements with Doom, what Doom looked like. But also want you to notice, besides how sort of pixelated everything looks here, that Wolfenstein only has walls in its environments that have 90 degrees. You don't get any other kind of things, which is why this looked like such a maze game. And, well, anyway, we can just carry on. How did this work, though? Well, it used something called ray tracing, where we would literally cast a ray from the player's perspective and measure the length of that ray. And if you looked at that from the player's perspective, it would use the length of that ray to draw a series of columns with the height changing depending on how far away the ray came. And, well, it also came with the advantage of you only needing to draw that which the player could see from their perspective. And this is what was called ray casting. Not to be confused with ray tracing, that's what you need one of these for. So Doom's source code was released to the public in 1997, and for those of you guys who still play Doom on DOS, if you had to ever dir out that directory and see what's in there, you'd notice that the biggest files were always the executable and the WAD file. Now, the WAD file would be quite big. It would make up almost 90% of the entire game, and WAD, of course, stood for where's all the data. And if you had to break open one of these, you'd find that only about half of it was graphics, 10% of it would be sound, a little bit of sound effects, and a lot of it, almost 30%, would be map data. And if you looked at the WAD compared to the actual source code that was released, the source code that was released was only for the game engine itself, and not the actual WAD file, meaning that you still needed to pay and get the WAD file to use with any open source solution that you created around that. So without any further ado, let's take a look at the source code itself. So the source tree starts with Doom v1, which was initially released in 1993, and then there was version 2, from which things like Heretic and Hexen and all those games were created by Raven Software. And then Doom carried on up until Doom 2. You've got to love the versioning number over there. And then Doom 2 got a patch, Ultimate Doom was created, Final Doom, Doom 95, you saw that thing with Bill Gates, and then Linux Doom. And Linux Doom is unfortunately the only version of this for which we have the source code. Why, you ask? Well, it's because of DMX. Not this DMX, but because of DMX lib by a company called Digital Expressions. Now, Paul Raddick at the time just said, sorry, but that's the way it's got to be. And John Carmack described it using the DMX sound library as a mistake. But John Romero was more vocal, calling the guy a shithead and a sound code dork. But anyway, now we've got the source code up on GitHub, and you guys all know how to go and pull stuff off that. But if you do grab the source code and check it out, you'll see this map that's quite useful. It shows you where all the video system files are, sound system, networking, the renderer, etc. And if you use Visual Studio Code to explore this, you'll notice that this is written in C, so there's a make file using GCC, which you'll use to compile this. And yeah, I always like to go to the main entry point of any program that I'm going to look at to see how it all works. And interesting how you can see all the different parameter options that you might not have seen over there. Things like no monsters, fast monsters, deathmatch, alt death, interesting things over there. And of course, this is what it would have looked like if you were studying the code, or what it probably looked like for not the original developers. They use next step systems, but what it might have looked like in something like Borland. But anyway, yeah, if you try to compile this, you'd probably have an issue building it, because modern compilers are all 64, but you'll need to do a lot of configuration to get the make file to do a 32-bit compilation for you. But one way to get exactly the same experience as what you would have had back in those days was to use Red Hat. Now, I do know Red Hat is a sponsor of this conference, but they're not paying me to say this at all, and you'll see why in a moment. So I'm looking at a copy of Red Hat from 2000, specifically version 6.2 called Zoot, that I ran in a VM to get this going. And I wonder how many of you have noticed the Netscape Navigator icon down at the bottom there. But anyway, if I wanted to compile this, I would open up a new terminal. If we zoom in just a little bit over there, this is the process you'd go through. So there's all my source code over there, and I would just need to create a Linux directory, and in that I've put a Doom2 WAD file, which is what I'm going to need. And then when I press make, or rather type make, I'm going to see the following output. And this is that make file busy building up our version of Doom, which we've now compiled. So if we go check back in our Linux directory, there's all our O files and our Linux Doom copy. So if we get that running, that's Doom starting up. That should look familiar to you. And there it is. It does mess up the graphics of the session, but the graphics of the game itself are perfectly fine. And it plays perfectly fine too. So I can just start a new game over there. And there we're going. So let's chat a little bit about how Doom works inside, specifically binary space partitioning, which you might have heard of before. So you might recognize this map. This is E1M1 from the original Doom. And if you considered the entire map as, say, root node A in your tree, you would then take your map and cut the whole thing in half and partition it into two, thus leaving one side on the left and one side on the right, and those would become A and B in your tree. And you'd then go and partition side B and create C and D in exactly the same way. And you do this until you've gotten the entire map partitioned this way in small, manageable segments that you can search through very easily in a tree. Now, if you've never used Flamegrass before, I'd very much recommend this for any type of code profiling that you want to do. But notice how, with the main loop down at the bottom and Doom main that we saw before, it calls display and then render player view and then draw planes and then render BSP node. And it does this 30 times a second. This is why Doom's frame rate is fixed at 30 times per second. So if we're going to parse this or traverse these BSP trees, we would go to point on inside, which is one of the parts in the code. And notice at the bottom there that we are busy. We've got a left and a right side of these fixed T objects, which are essentially the nodes in our tree, which would later on call render player view, which would then call display. And if you scroll down there a little bit later, you'll see there's render player view, the HU drawer, that's your heads up display and full background screen. And how this would actually work in practice, if you imagine a player's position and a player view that we need to render, we would have a segment that we'd need to draw, which would have its own XY coordinates for the two sides of that segment. And on the screen, we would use the same raycasting technique to determine the height of the columns of those two pieces. And then we'd do some calculations to create a view angle box to be able to determine what that segment should look like. So if we had to move around inside a map like this and then stop, this is what the actual rendering would look like. And notice how it's rendering the things that are closest to us first, because it's not going to waste any CPU or processing power rendering anything that's further away. And then it renders stuff in the background. And this is going to be the draw planes method that's drawing those bottom, like the floor, ceiling. Well, there's no ceiling in this scene at least. You can see it draw everything up there. So that would all happen 30 times a second. And this would be the render player view that's doing all of this. And view draw planes. Plane drawing is also a little bit interesting. So here's just another view of the same thing happening. But yeah, let's give this a second just to run a little bit. I should have sped this up, I'm sorry. But there are the planes being rendered as well. And it's interesting how it does them as triangles in some cases. And again, everything you're seeing here is slowing down. And this would be drawn 30 times a second. Oh, and speaking ahead of its time, this is really interesting. It only works with Doom version 1.2. But if you've got 3 computers all networked together, either via a modem or preferably a serial cable in this example, here's an example of this being done in not VirtualBox, DOSBox actually, is where you would be able to play the game with 3 screens networked together, but it would show you the left and right angles. And this is something John Carmack did. So very impressive for its time. If you consider that this is 1993, 1994, immersive virtual reality was close to it as you could get. So it's actually no wonder that John Carmack ended up at Oculus working in 3D immersion and those kinds of things. So in 1997, the Pathfinder mission spent about 9 months getting to Mars and gets into the atmosphere, fires some retro rockets, lands on a balloon airbag-based system, and becomes the first functioning rover to work on Mars. So this is what the lander looked like. There's some stereoscopic cameras that gave some really great panoramas, and the rover itself was called Sojourner and would travel around and look at rocks and take little samples with a spectrograph. But we want to know what kind of CPU this thing ran. So let's take a look inside. This is all of the rover's circuitry, and if we zoom in, that is what the CPU looked like. And it's a ATC85, similar to commercial models that would look like this inside, and popular in things like the IBM Datamaster from the 1970s, or the IBM PC-XT, which some of you might remember from the early 1980s, that ran the very popular Intel 8088 chip and looked like this. But the ATC85 ran at only 2 megahertz. It had only about 70k of RAM and 512 kilobytes of storage. And the rover would communicate back with a kind of walkie-talkie system equivalent to a 9600 baud modem that, after error correction, only really worked at an effective 2400 baud. So the rover could in fact only communicate back to Earth in bursts of about 2 kilobytes up and 2 kilobytes back, sending photographs like this one. But what kind of operating system did this thing run? Was it PC-DOS that was popular in the early 80s, or maybe MS-DOS? No, it had no operating system at all. It used something called a cyclic executive, which in code is very much just an infinite loop. It's an alternative to a real-time operating system, and this is how all of the rover's functions were implemented in C. But does it run Doom? Well, I'm afraid not. We just don't have enough MIPS for this thing to run Doom. So in 2004, coinciding with the same year that Doom 3 came out, a new pair of rovers end up at Mars, the Mars Exploration Rover, or sometimes called MER or MERS, because there were 2 of them. And these things landed in a very similar style, using retro rockets and airbags to bounce around on the surface. And this is how Spirit and Opportunity became the new rovers on Mars. But of course, you've probably watched a lot of documentaries and know a lot about these rovers, but you probably don't know what's running inside. So let's take a look inside. And if you were to disassemble one of them, you could draw out this PCB card. And what you'd want to be looking for in the top corner over there is its main CPU. And that is, of course, the BAE Systems RAD 6000. And it's part of the Power 600 microarchitecture. So this is basically the radiation version, or the radiation hardened version, called the RAD 6000. And then there was also a much earlier version, the IBM PowerPC 601 from 1992, so from many, many years before. And this CPU was actually quite popularly used by Apple in its first series of Power Macintosh computers, the 8100, and that CPU being clocked at 80 megahertz in 1993. So the rover had a RAD 6000, downclocked a little bit to 20 megahertz, 128 megabytes of RAM, and 256 kilobytes of storage. And the rover could communicate back to Earth either directly, at sometimes as low as 500 bytes per second, or use a satellite and go up to 256 bytes per second. But what's interesting is the operating system, which is a real-time operating system by a company called VxWorks. Here's just an example of what VxWorks 7, one of the later versions, looks like starting up. And VxWorks is, being a real-time operating system, doesn't work on processes, but more this concept of tasks, but we'll definitely get into that a little bit later. And it's just fun to note that all of the rover's control software was written both in C and C++. But in 2009, The Spirit rover was driving up a dune and sadly got stuck, and by 2010 it was game over. But I have always thought that that might have been an opportunity to upload some interesting stuff into that rover's memory before it was lost. And sadly in 2018 the surface of Mars was covered in a dust storm and we lost the Opportunity rover as well. And as sad as this is, I do love and snicker at this tattoo with a sort of poeticized version of the last message that came from the rover. But notice that that is not the Opportunity rover, that's in fact the Curiosity rover. So would any of these have been able to run Doom? Well, if you look at the RAD 6000 against the absolute minimum you need to run Doom, being an Intel Thread 6, the RAD can do it. It's got 35 MIPS versus the minimum of about 11.4. And because it's clocked down on the rover to about 20 megahertz, it could still do it. So it would seem that we're in luck, but none of those rovers are running. So let's see what else we could use. So in 2012, something interesting comes to Mars, or something curious, let's say, and uses this awesome sky crane thing, which is quite different and extremely impressive. Now, most of you have watched documentaries around this, but this is, of course, the Mars Science Laboratory, or MSL. And we want to know immediately, does this thing run Doom? So let's look at some system requirements. Well, we need to consider the CPU, the RAM, some hard disk space, of course, some networking, just to get some software on there, of course, what type of OS it's running, some power, and maybe a display, some sound, and a keyboard and mouse. So let's take a look inside. And this is what Curiosity looks like when you pop the hood open. And I know what you're thinking, but no, that is not a CPU cooler. It's the SAM, Sample Analysis at Mars unit, and it's actually what the drill deposits dust and drilling samples into, and it uses this kind of vibrating sieve where it can actually make a sound. And there's this story that every year on its birthday, Curiosity sings happy birthday to itself. That's actually not exactly true. It only did it once in 2012 or 2013, obviously. And I don't know, this kind of got me thinking about the difference in the atmospheric pressure between Earth and Mars being quite phenomenal. And I thought, well, maybe, just maybe, if you get the drill involved, you could do something like this. Some of you might recognize this. This is called the Floppytron. It's just a bit of a retro thing where, yeah, they've programmed this thing to be able to play MIDI files. I just thought that was a fun thing, but not probably. Let's get back to the CPU though, and if you're looking back into what Curiosity looks like inside, this is probably where you should be looking. And if you had to draw one of those cards out, eventually you'd find this one. And on that you would find the PowerPC RAD 750 CPU by BAE Systems. Now that's what it looks like inside, and no, it doesn't run at 200 megahertz as most people say, and what the spec says. On Curiosity it actually runs at 133 megahertz. It's got 256 megabytes of RAM and 2 gigabytes of storage, and it's actually got all of this twice because the rover has two different computers, A and B, and it switches between the two of them depending on whether or not one is giving issues or if they want to create software updates or anything else like that. So from system requirements point of view, we've at least got enough CPU, RAM and storage to maybe get Doom running on this thing. So I was thinking about how I could test this myself, and the PowerPC RAD 750 20 years ago costed $200,000 back in 2002. So in 2020, that's almost $300,000, or more than 5 million South African rands. So this got me thinking that the CPU is, after all, part of the Power 750 microarchitecture, which includes the radiation-hardened version, but also a Motorola version used by Apple in some of its computers, and by IBM. So if you look at the Motorola version, this was popular in the late 90s, early 2000s, and was also used in the original iMac. So I went out onto OLX and bought myself one of these for about $2,500. Went onto Gumtree and got myself an equivalent laptop from 2001. This is an iBook 3G. And then I went on a bit of a rampage because along with the G3, I needed to get the G4 and the G5 because I needed all the PowerPC Macs. But that's probably for another talk and another day. But this left me in a position where I had some comparable systems that I could actually run this on without using virtualization or anything else. So I could rely completely on bare metal to see if I could get this working. Now, the operating system becomes another concern, and the Curiosity rover runs VxWorks just like previous rovers, specifically version 6.9, not the latest version 7. And if I want to compile Doom for VxWorks, well, I went and got myself a copy of a much older version that uses VxWorks version 5. This is Tornado, that you'd use to create either a bootable image or a task that you could upload to something that's running a different sort of image. Obviously, it runs in Windows XP, just to kind of mess around with. And initially, I'm just going to speed this up a little bit, but I created my own little Hello World just to prove that I could get a task running in VxWorks, where I could be running Doom, or at least just, get something printed out. So at this point, it was time to add in the original Doom source files and start working on a VxWorks version of this. And, well, first you have to pull in the headers and then the C files, and I've sped this up as well. So, yeah, this is quite a good IDE for its time, I reckon. It helps you manage dependencies between different classes, but I quickly ran into some pretty serious errors and issues. And this was incredibly frustrating. If you just look at one of the first ones over here, look at that dthinkh line 48. And if you go open up the file, it does have a semicolon. I don't know what this thing's complaining about. It does have a semicolon. So I kind of gave up on that. VxWorks has multiple security issues in any case, and while we're not going to explore that in this talk, it is interesting to consider how many issues there are. But the makers of VxWorks also create something called Wind River Linux. And Linux is a good option. It would be able to run on this kind of hardware. So for the hardware I had in mind, I chose Yellow Dog, which was a derivative of Red Hat actually, and got that on my iBook and started messing around with that. So first loaded up my source files. Now I needed to make some changes that I'll chat about a little bit later to get this working on a Power PC, because we are working with a big endian and not a little endian CPU. But if I click make, it goes on and creates an executable for me, and there you can see I've got a Linux Doom executable like I had before, and it runs just fine. The colors are a little bit messed up because, like you saw in the previous version where I ran this on Red Hat, every time I wanted to do a screen grab, it messed up the colors of the game, but it's actually the other way around. The game's colors look fine when you're actually playing and interacting with that X window. And of course it ran fine on my iMac 3G as well, and all of the other Power PCs, and I've put this up on GitHub for you guys to take a look at and mess around with and contribute to if you like. So it really looks like we're making progress here. So why the massive price difference between a RAD 750 of 5 years ago and an iMac 3G that would have costed me almost 200% less 20 years ago? Well, the answer, Duke, is radiation. Radiation obviously pouring out of the sun, radiation that we need to deal with when we travel through the Van Allen belts, radiation as a result of supernova explosions in other galaxies and our own, and the general cosmic background radiation that emits tons and tons of particles out in space. And one of my favorite papers that I've found regarding this kind of stuff on the effects of radiation and specifically cosmic rays on DRAM came from a study they did in 2009 on some Google servers, and they found that for non-error corrected memory, the mean error rate amounted to 3,751 errors per year. So think about that the next time you have a bug in your software. But anyway, radiation hardening is of course what we're chatting about and why this is so expensive. And you get a bunch of different scenarios that can come up, specifically things like single event upsets, latch ups, and gate ruptures, which sound pretty serious. So let's take a look at why and how this kind of stuff works. Most of you would have seen a logic gate represented like this, and it's pretty much the hardware equivalent of what you could write in software like this. And yeah, if we take inputs A and B at the top there, if I put in 0 and 1, of course I get 0. If I put in 1 and 0, I get 0, but if I put in 1 and 1, I get 1. So how does radiation affect this? Well, let's look deeper inside a gate and see how to build one. And to build an AND gate, you'll need 2 transistors. And if we add some current in on this side and put a 1 in on that side, so we're adding in current from this side, it'll open the gate and the electricity will flow through to the next transistor. And if we put nothing in there, we get nothing out, which is a correct AND operation. And of course, if we do put some current in on the other B side, current will go in, it'll open up that side, it'll ground, and we'll get a 1, and our transistor works perfectly. However, if we wanted to zoom in and see what these things actually look like, everything's based on a silicon substrate. And if a high-energy neutron had to smash through the inside of this NPN transistor, the substrate would get damaged and we could end up with a short circuit between the two sides. And as a result, our transistor would always be on. So if we try to turn it off, this would be incorrect. And that would kind of show you all the different things that can go wrong with your transistor, and thus the massive price difference for all the proprietary techniques that companies like BAE Systems go to make these things cost as much as they do. So let's chat about power just for fun for a second and consider what type of PSU a rover like Curiosity uses. Well, it actually uses something called an RTG, or radioisotope thermoelectric generator, where it's got scalding hot plutonium-238 inside, and it takes advantage of that to create electricity. Plutonium, of course, having a half-life of 87 years, so it stays hot for a very long time, and using thermal couples in an RTG like this. This is Curiosity's actual RTG. It actually takes 4.8 kilograms of these square-shaped pieces of plutonium. But yes, that gets mounted into the back of the rover over here, and that's what gives it power. Very similar to what you see on some of the other Voyager and Pioneer spacecraft, where they're kept a little bit away from some of the instrumentation. So that at least solves the power problem for us quickly. So let's talk about networking, specifically the deep space network, and how we communicate with rovers on Mars from Earth. Now, at its best, Earth is only 54 million kilometers away, and it takes about 3 minutes for a signal to get there, traveling at the speed of light. But at worst, when we're on the other side of the Sun, it's 401 kilometers, or 23 minutes, and that's almost an hour for signals to get there and come back, and there's all the processing and relaying that happens in the meantime. So of course, real-time communications, or popping open an SSH connection, is not an option. But how does this network even work in the first place? Well, they've got the massive Gladstone antenna in the United States, another one in Australia, at Canberra, and another one in Madrid. And what this does is they have overlapping signal, which means that Mars always has at least one antenna pointed to it at any one time, and where they can maintain constant communications. And once you're on that side, you can take advantage as a rover on the surface by using the Mars Odyssey, or Mars Reconnaissance Orbiter, or the ESA-built Mars Express orbiters, which can all relay communications back to Earth much faster. So some of you might be thinking, is this an opportunity for software-defined radio? Can we use dongles that are cheaply commercially available to pull data out of this system the same way we do from weather satellites? And the answer is absolutely not. If you look at the Gladstone antenna as an example, this thing is 70 meters across, and even if you could plug your SDR into it, you'd probably need to cool your SDR down in liquid nitrogen to get it sensitive enough to be able to pick up the signals required, especially if you're going to communicate with even deeper space probes. So when it comes to new ways of putting yourself in jail, this isn't an option I'd recommend. So let's consider the last system requirements we're going to have here, specifically the display and the keyboard and mouse. And I know what you're thinking, the rover doesn't have any of these things. And if you look inside and consult the spec sheet, you will find that it can handle something called compact PCI. Now, this is not your regular PCI that you might remember, but more a backplane like this that all those boards plug into. So if you did find this rover, or you used the one in the Mars yard, you could plug one of these into it and get some HDMI outputs, but that's probably not feasible for what we want to do. And for fun, we can think about what we could do with that laser, but it wouldn't be a feasible way of projecting anything anywhere or actually using that as a display. So Doom's Linux version actually uses the X Windows system, and here's typically what it looks like. So when you run that, it starts up X in the background, which is the default Linux window manager, and there you've got it working in an X window. Now, one of the things I want us to consider are demos, and Doom has demos where it records key presses. And one of the ways in which you can do this, and this was a very popular way of distributing files and demos of how people had done things in Doom. But anyway, if you want to record your own one, here this is my compiled Linux version. I just tacked in there record, and here I'm shooting some zombie men I'm recording to a file called my demo. And notice that I've included just a little bit of more output, so whenever I fire the gun, it says weapon fired. You press Q to exit. Don't worry, that's not an error, but you do have that LMP file. And if you just go double check by doing a quick ls on the directory where we've been running Doom from, you'll see we've got this file, and it's quite small. So awesome. How do we play this back? Well, you're just going to tack on the play demo option and refer to the file. Now you must remember to always take the extension off, but here I'm not touching the keyboard and it's playing through exactly the same demo that we had before. And that's pretty useful. That might be a viable way of running Doom on something if we didn't need the screen. So let's take a look at that. I made some modifications to the source code and added a new option called no display that I could add. And I could then run this and not get X up or initiate any of the video stuff, but still run the core game. So if I run this now with no display and I play my demo file, meaning I don't need a display or a keyboard now at all, notice that it's not bringing up anything, but it is busy playing the game and running the renderer and everything else. It's just not displaying it to anything, and it is running in good time. So I've put this all up on my GitHub repository for the Mac version. I'll port it over to PowerPC soon, and yeah, that's something fun to look at. So at this point, we can probably safely say that the display, sound, and keyboard are not even required, and this whole thing of running Doom on a rover is probably plausible. So finally, I'd like you to consider that many years from now, somebody somewhere is going to find one of these rovers, and they're going to look at the memory of those rovers, and wouldn't it be grand if they found something more fun than just a plaque or a golden record, but actually an interactive piece of history that they could play with and mess around with. It even comes to mind that if maybe aliens or someone hostile had to find this, they could have some fair warning about what we here on Earth are all about and what we're into. But yeah, with that, all the best to the Mars 2020 Prosperity rover. I've got my name on that rover. I'm one of the almost 11 million people who's made my mark on that. And I'd like you to encourage what kind of mark you want to make and what kind of mark you want to leave. That's it from me. Here's my GitHub and Twitter. Enjoy the rest of your conference.